There we go. Um, the the main thing I've seen in the last, I would call it since about November, which was really the big onset of things like Claude and Claude Code. Obviously, you have ChatGPT and all these other vendors with all these different AI tools that are available to you. And that was kind of the word that I've been hearing the most is that AI is a tool. We're just going to add it to the thing. It's one more thing to the classroom. But realistically, things changed a lot in November when we had the launch of Claude Code, and now everybody's fighting for that top spot, working their way through. Um, it changed more from just a tool. It's not really a tool anymore. It's kind of a way of life, and if you understand how it truly works, it changes anything that you've ever done in the past. So I encourage people to utilize it, use it in the classroom, and really change the way that they go about teaching students. I can tell you, I pretty much gutted all my courses that I've ever taught, and there's at least a strong AI component in every single one of them. And a lot of that came from student feedback, not just when I was playing real hard with it last fall. I think we had a winter session that I did here, and it was getting pretty big at that point. But students are coming back from interviews saying, "Look, they asked so many AI questions that I knew nothing about." And so the whole spring semester, students were trying to ramp up in AI, and they just couldn't get there to get job interviews because everybody knew what the interviewers knew the terminology they were supposed to ask. They had no clue what they were even asking the question of. And it seems to be more and more apparent from HR and companies right now that there's the buzzwords and they will ask the buzzwords, but they don't even know if your answer is true or not. They just know they're supposed to be asking those things. So hopefully we can get some of that into the classroom and into your guys' skill sets and kind of prepare everybody for what's coming because it's definitely changed a lot. I spent upwards of 80 to 100 hours a week back around Christmas time, really focusing in on this AI stuff because I could see a massive shift in what was going on. And that led to some good things. That led to me starting a different software development company and working with some other groups. As far as a background on me, I don't like spending time on myself, but right now, the main job, so to speak, is a professor here at Fort Hays State University. I'm going to do that for about one more year. This will be my last year here. Here, I am the director of operations for the Cybersecurity Institute as well as the Information Enterprise Institute, focused on the CAE and running our master's program for cybersecurity. We have a master's program for information assurance, which is that compliance piece we're going to be talking about in this week, and then the undergraduate cybersecurity work, which runs alongside of our computer networking programs. And then we had just recently have Comp Sci has joined our department, and we're kind of mixing the two of those together. So they're going to have a little more of the theoretical side of AI and the foundations, the machine learning aspect of it. And then we ramp it up high in the skill set side of using that in the cybersecurity and computer networking, and a lot in the infrastructure side of things. So there's a few things I'm going to kind of show you throughout this week. And again, if you guys have any questions or you want to shift or there's something not being covered about, again, those have been in my sessions know that I love doing that. I can shift to a whole different day or we can shift different concepts. So outside of that, I do have a cybersecurity consulting company. And so that's where I try to make sure that I have those skills that are still out there in industry. We primarily do access control, physical security, and some managed IT. And then the more recent one is the software solution side. And so a lot of that is dealing with businesses, whether they're small or large, depends on what you call a small or medium business these days. But going in there and really determining what is the best course of action for them to get greater velocity than what they're doing today. So a couple good examples, ones I've worked with, they had about 3 or 4 people that were doing pure data entry, and that was never meant to be that person's job, but that's just kind of how the job worked out. They were doing manual data entry into a slew of Excel sheets that were all disconnected and disjointed. Data was getting dropped everywhere, and it was causing massive inefficiencies and a massive loss of income. Within about 3 months there, we were able to change a drastic portion of that to where now we're relaunching everything. But we've taken that from 3 full-time positions down to a 15-minute job that one person can check in the morning. And those 3 people are now freed back up to go make better business options, go out and work and the marketing and the sales side of things so that they can bring in more business for the company. So that's kind of what I focused into. And not only just working with those small businesses, some of those are AI tools, some of them aren't, but a lot of it's just getting customized software packages out significantly faster. We we started out with your general software development side of the house that could take months, and we've done software packages in less than a month that would take 12 months prior. You can get up to about a 40x multiplier right now in software development. The real problem is you got a bunch of these vibe coders out there that are just slinging code left and right, and they're not doing it in a secure fashion. They don't have that background knowledge to know whether or not I should have chose that or I should have chose this, and just rely on the AI to do it. And there's a time and a place for that, but you definitely want to do it in a way that you can train students to do it securely and at least have some checks and balances in there. So I do have a couple pages we can look through of what that secure infrastructure looks like or how to run that ops infrastructure. I know most of your guys' background, it looked like, was in the cybersecurity networking style realm. Um, how many of you guys have ever ran any kind of infrastructure ops? So servers, software packages, deployed virtual machines, Docker containers, that kind of stuff. Does anybody have those type of skill sets? Okay. Fantastic. And that's really what I've seen in a lot of this. I mean, I came from the smaller schools too, where it's a one-man band kind of thing. So here at Fort Hays, if you're familiar with the NetLab system, I worked with NDG for about 7, 8 years. I ran those systems here and I ran them for other schools. But having that background, that infrastructure type thing really makes it easier in the classroom to kind of explain those skill sets. So, and that's really going to be a thing for this week. So as we work through our lab environment, while I do have some online VMs that you can access there, if people aren't able to set up their laptops, we really want to have you deploy this on your laptop if all possible. So as long as you got some specs, I think we can make a lot of this work. I think I say 16 gig, but frankly, you can make it work with 8 gig. And it's really not going to consume a ton of that. However, if you guys have ever played with AI side of things, RAM, CPU, and even GPU specifically is significantly important. Now, everything that was built for this week, I did without a GPU, making sure that we can do the idea and the concepts without you having to have thousands and thousands of dollars worth of equipment. And it's hard to have that in the classroom at every single school for students as well. So we're gonna train as if you can do it locally, and most of the labs that we do are more than capable of doing that. It's the only good way of you understanding how things run under the hood, so to speak. Make it easier to teach in that fashion. And then, of course, you could always ramp those up by utilizing some heavier resources there. And again, if you got questions on that along the way, feel free to do so. So just kind of an overview of what we're looking at this week. It's really just going to be a 5-day track of looking through IT and the cybersecurity for grading towards a CompTIA Security Plus or Sec Plus, I'm sorry, Secure AI exam blueprint. So I'm hoping everybody has a little bit of those skill sets that we kind of put out early on. Every lab is going to ship as a downloadable Docker Compose. So if you don't have Docker set up, we're going to spend a little bit of time working on that here today. I figured I'd get through this introduction piece, and we're supposed to have a break at 10:30, and then we can kind of jump right into that piece of it and talk about that. Let's see. Are you planning on creating NetLab labs for this content? Johnny, I'm not, but I could possibly do that. Everything I did was built in Docker, so portability over to NetLab is pretty straightforward. You would just create a VM with the Docker Compose, and then they could load up the labs from there. So I can even give you some scripts that would take what I have here and make them available as VMs in NetLab. That's pretty straightforward. I used to do a lot on the VM side and be pretty heavy on that, but with Docker's a little bit easier to light up a lot of these different services and get more bang for your buck on your resources than having a bunch of VMs. So it works fantastic in the NetLab environment. This is how I use it on my side, but it also gives some people some chance to run things locally without having to have the heavy lifting of a full VM. All right. And again, if you happen to be working on a school laptop or any of that kind of thing, um, and you can't do Docker or you can't get that throughout this week, there are going to be some online services that I have some access to. I think I've got 13 of those slots available for today. I'll have some more here tomorrow, but it'll at least get you through to get it set up. And if you have the ability to do something with a laptop or a, uh, a small computer or extra computer, that kind of thing, it'd be a great way to do it because especially if you're going to use it a license in the classroom. If you have a full-blown server, which I know I talked to some people last time, they had a small server or what they had dedicated as a server. I can help you get that infrastructure set up and how that would be best utilized in the classroom. Let's see here. Good question came in was, have I done roll call? And I haven't yet. And I was kind of waiting to get about 15 minutes in here to see if we have some. It looks like we're still missing some stragglers, but I'm going to run through here real quick and mark that off so we're good for today. So let's see. Looks like Daryl Andrews is here. Mark him off. Let's see. Beverly Brooks. And scroll through here. I believe I'm missing that one. I'll come back. Why, Dean, are you here? Okay. Bye. Donald Easton. Let's see. Donald, are you here? Rivera's here. Good. Terry's here. I'm just going to swing this over here so you guys can see that. If I'm missing your name, holler at me here. Let's see here.
Good to see you, Jason.
Yeah. Let's see. Great. I saw Wendy earlier. She is. All the names are matching up here, but we'll see if we can get them all.
Hi, good morning. I see you skipped my name. My last name is different. That's the problem.
Oh, okay. Which one
I
was
am
it?
here. I'm Chidinma Onabolu. It should be Agu.
Okay. Perfect.
Thank you.
Okay. Did I miss anybody up there at the top? Three. Three actually seems to be pretty close to matching up with how many I'm not seeing in here. So any of the three up here, but I missed you? Okay. And we'll check back in here after lunch. That's usually, if you haven't done these before, we kind of check them first thing in the morning and then right back after the lunch hour. And with that being said, does anybody know they're going to be out a little bit this week? Have some conflicts? If so, just feel free to message me in here, and that way I can kind of keep track of that and move forward through there. A lot of the morning time is going to be going over some content and some slides that are in there, but I intend for this to be more of a workshop. This isn't going to be a listen to the lecture kind of thing. I want those hands-on experiences. And then as you guys come up with ideas, I can generate a lot of that in the background, whether that's additional labs or what we would do to spin that kind of thing up. I know, like Terry mentioned there, he's looking to set up a mock SOC. And that's something that I did last fall with my students, and it went fairly well. With now we have a concept of a SOC in a box kind of thing where you can kind of deploy it out with a bunch of Docker VMs and other containers and do everything that would be in a real SOC there. So really happy to share those kind of things, and we can talk about how this stuff would play into that, particularly when it comes into the infrastructure as a code and utilizing some of these AI tools to get you there significantly faster. I myself have to get that built out for this fall, so walking through that wouldn't be that hard. That's really what I have of interest from you guys as we're going through this week is how would you like to integrate it to the classroom? And if we need to build some of those materials as we go through here, by all means, we can certainly do that. All right. So we got the roll call in. As far as the week, like I said, today we're going to really just kind of look at the AI foundations, shared vocabulary. A lot of what I have sped up for time today is making sure that people have their Docker infrastructure and getting their laptop set up. That usually takes quite a bit of time on the first day just to get everybody at the right place. For those of you that again canned and missed it, I do have some VMs that you guys can SSH into online, and those are available. Cost-wise, if you guys had to do that in the cloud, I think I'm running all 13 of those for $110 today, something like that, maybe a little more. And that's only because we're dealing with this AI content. So they got to be some beefier droplets or VMs or whatever whichever vendor that you're choosing to use. Today, the ones that we're running are all off DigitalOcean. I tend to use them quite a bit for some droplets and little container VMs. And so you guys will have access to those. Tomorrow, we're going to focus on the threat model and how to bring in some of the OWASP and do some prompt for firewall stuff. That's one thing that I've done at another company is we've rebuilt their Palo Altos and their OpenSense boxes and being able to build dashboards with these kind of tools now to monitor those, see the threats coming in, consuming the logs, and being able to analyze that faster because we just can't have people sit there and look at those like we used to. And AI can do a significantly better job of doing that. So what it looks like to build those out and then protecting the actual AI infrastructure that we have may set up at our location. Wednesday, we'll get into depth and defense and kind of rules of how to set things up. And then 4 is really focused on AI as a SOC, where we're going to try to build out this infrastructure, kind of like what Terry was asking for there. And I think a few of you other ones really wanted to do that as well. So we'll be more than happy to kind of go through that. If you guys are tied up, looks like some of you may on Thursday, it's all going to be recorded. And you guys will get access to all these materials. And then Friday is really going to be kind of reviewing all the domains and everything from the CERT exam. We'll have our exam that we're going to take here in this class, as I think they mentioned you guys have to pass with an 80 just to get your Credly badge. And then in the afternoon, it will be access to more labs, me kind of expelling all the resources and content and Docker VMs or anything else we build this week. I'll make sure all of that is tied in there as well. As far as some prereqs for this week, most of you already have this kind of security plus type knowledge, not necessarily the CERT, but you at least have the basic knowledge, the networking, that kind of thing. Hopefully everybody's comfortable working with the terminal just to get things fired up. You can certainly use the UI versions of Docker and things to get you moving there, but shouldn't have too much. We'll use Docker Desktop for that. The ability to work a little bit with Python scripts. It's not like you're going to be editing or writing a lot of code here for Python at all. It's really just the ability to kind of understand what's going on there. And we can kind of show you that. We'll also have some bash scripts that are just making things easier for you. But it's good that you should be able to know how to review those and not just blindly running those. SSH client, pretty much everybody has that built in now, whether it's Windows or Linux, so I'm not too worried about that. It does say 16 gig. That's only really one lab that requires that much there. Most of these other ones we can get away with significantly less. All right. So I'm going to kind of move on to the setup, and this is just to get you guys this infrastructure kind of going. Again, we've got about 7 minutes till the break, so I figured we could kind of start that, and then everybody can use their first break, and we can get some infrastructure up and going. So to get this piece set up, Docker Desktop's the big one. If you don't have that already installed, it's available out there for Mac OS, Windows, and Linux. I encourage you to use the desktop version as it gives you a nice little GUI that you can kind of work with. You should be able to see something like this here. And so you can see a couple test VMs that I've been working off in the background. You guys will kind of utilize this front end. And to get that downloaded and installed, you guys can get that from this URL here. It's pretty straightforward. And then just opening up a terminal and making sure that you have the right Docker versions and things are matching up with Compose. So you can run a quick smoke test, make sure your Hello World container is up and going. And if that all looks good, then we should be able to kind of start in with the start of things. Some quick notes for you Windows users. You'll want to enable WSL2 in order to make that work. It'll require it as you go to install it. It's not a big deal. It does work pretty easily. Everything we do will need to be inside that WSL terminal, not necessarily PowerShell. And then any kind of Linux users, you can, if you were just using Linux console, you don't necessarily have to have the Docker desktop, but I do encourage you to do that if you are running a desktop. So I'll kind of pause here. Is anybody going to have any real trouble getting Docker desktop up and going on their resources for this week? Again, you don't have to be a Docker expert as we're working through this week. We're going to get you the resources in order to run that. You essentially just have to run a command to get those VMs up and going, and then you can kind of run from there. You would be a better option than an LXC. You can run these on there. It just depends on what kind of infrastructure and how you have it set up. So a good question. A lot of people will run like a little Proxmox VM in the classroom. I think that's what Chris is talking about there. You could run these as either a VM with Docker and run them under there, or you could do it as straight LXC containers on the Proxmox setup, or even on your laptop if you wanted to. In this case, they're all kind of shipped out as Docker containers because it's easier for most people to execute and pull up, but you can certainly do that. Yeah, and Terry's right. In these workshops, we've ran into some issues with people getting Docker desktop installed or just Docker in general. So let's see. So Wendy, on your side, I can get you command here. Give me a second. Okay, Marla, I'll get you a code here for today. On the install there, you can either do per user or all users. I would do all users if it's your laptop or anybody else that's going to be using it may use Docker. I'd go ahead and just open it up for everybody at that time.
Hi, Jason. I didn't see any links to get the container file for this.
We'll get those when we get to the actual labs.
Got it. Thanks.
Yep, no problem.
So for the Docker desktop, do I need to use the paid version? I see I have 3 options to select from. The personal one, would that be sufficient for this course?
Yeah, personal. There's no reason to use the paid one at all.
Okay, thank you.
Like I said, if you have access to a little Proxmox box or something like that, you can definitely use that side of things. Even for this, you could just set up a little VM with Docker on it, and that would allow you to follow along with what we're doing here today. whether you want a full desktop over the top of it, or if you just want to run like a Linux server with Docker on it, you can certainly do that. You just essentially follow these directions on this side. I think I got out the codes to the ones that mentioned that there. Let me actually put some names on there so I don't lose those. If you didn't get a code from me on my side and you still need one, just message me there. I can send you one. I still got several slots that we can use. I'll kind of let everybody do that here up through the break. Again, we're going to break here at 10:30. I'll pause the recording. And then I believe we come back at about 11. And then from 11 to 12, we'll go through this first setup, kind of day one materials. We'll go to a lunch break from 12 to 1. And then when we come back in the afternoon, we'll get into some of those labs. We'll have another break there at 3. And then we'll kind of finish out the day there. So,
Is this file available somewhere that you can access? The one you're showing us on screen?
yeah, the one on the screen, you're more than welcome to grab this URL here at the top.
Oh, okay.
And this will be open here for the whole week, everybody. All the materials, all the downloads, everything that we do this week, I'm going to put in here. If we build extra resources, which tends to happen at these workshops, you'll get download links here on this extra resources page, that kind of thing. All right, I'm going to go ahead and pause the recording. Yeah, there we go. Thank you for that. Thought I had unpaused it and it paused it back. Great. Thanks, Chris. Appreciate that. So with Docker up there and going, you should have access to the SSH client. This is just how you're going to get access to that Docker VM once you get it up and going. You can have Git installed. We're not really going to pull from any repos or anything here. I may end up putting all these in a simple Git repo for you guys to pull down at the end, especially with all the little packages and files. That's sometimes easier to do. If you don't have the ability to do that and I handed you out a code, you can follow these instructions here, and that will get you into the same setup going through there. The last little piece is on day 5. I'll send everybody a code. This will let you take the exam. Again, because I got to turn in a grade for everybody at the end here. That'll be the exam that's kind of tied to your name, so we can get that grade passed on to NITIC. So we'll get started here with day 1. And so on slides, you're going to see the slides for the day. I'll go through the actual content. We'll go back through the slides. And then we'll jump into the labs themselves because it'll kind of walk you through there. So actually, I'm going to sneak forward and just go into the slides. Most of today is kind of focused on those basic AI concepts. And again, this is not you have to sit here and listen to me. If you've got questions, by all means, raise your hand. Just come off mute. You don't even have to raise your hand. Because I do like to treat these as workshops. And you guys have just as much knowledge as I do. So if you got something to share, by all means, bring that in there. All right, so we'll focus on some of the core AI machine learning terminology, such as model, training, inference, embeddings, tokens, and context windows. We'll kind of explain how those LLMs work at a high level. I think from what I was seeing in your guys' skills that you guys had sent me, that a vast majority of you at least understand the concepts of AI and have primarily worked with large language models, things like Claude and Copilot, ChatGPT, NotebookLM, Perplexity, all these other ones out there. So it's a great start. And I would hope that everybody has done that at this point. If not, you definitely need to get started because you're way behind the 8 ball. And just learning how those work and how you can move forward with those is a pretty good shift. And if you've been around since the beginning of some of those, like when ChatGPT first got released, that's why everybody said they were a tool, in that they weren't extremely efficient and they were not always accurate. And that has changed many, many times over the years. And some of the models that we deal with now are extremely small, very lightweight, easy to use, and are accurate as they move through. But there's different tools for different things. And so using ChatGPT to write a bunch of code, can you do it? Absolutely. Is there much better tools out there for that now? Absolutely. So, even ChatGPT has its Codex, which is its version of its CLI editor. We have Claude out there who has Claude Code. And of course, there's a bunch of different products off each one of those vendors. Those are by the two biggest frontier ones out there. In terms of writing code, I would say Claude edges that out pretty easily. Codex definitely has its place. As a matter of fact, I use both. So in all the software development side, I let Claude drive the vast majority of it, but everything is cross-checked with Codex, especially on bigger projects. And then I usually have a third-party LLM set up to kind of go back and forth between the two if they have questions or concerns. I'll have a third party kind of step in there and look through that. And then obviously I'm automating that and analyzing everything that comes through too before accepting it into actual code. So having multiple now is kind of the way of life. You can't just use one and kind of push forward. And the tools that are out there are increasingly dangerous. And I saw some of you had used things like OpenClaw and some of these other ones that are out there, and they're great, but they're not very secure when they go through there. And so there are some better ways of doing those, especially if you can host those locally. In the classroom's a great example for that. So students in my classroom last year, we set up multiple AI tools and got them to run very small packages, but it was good because they understood what was going on. And that's a lot of what we're going to do in this workshop. But then what it took to scale that. And so what would it look like for students to want to build out multiple ones or have a coding event or something like that? And at the end of the last semester, we ran an AI hackathon. And so how many of you guys have been a part of a hackathon and understand what a hackathon is? Okay, great. So hackathons are great ways for students to try to innovate and understand how to build maybe a new company or new software or a concept or an idea, and they want to chase that. Now, the word hackathon or hack is in there, and everybody thinks it's like a red team, blue team type pen test and that kind of thing. And it's not the same thing at all. A hackathon is really about coming up with software development ideas or business ideas and then being able to piece that together in a short term. A lot of them typically did this like over a weekend. So you would come up with concepts or ideas, the students would have to do research and then put out a presentation that they could try to get investors to come in and do that. And while that's great, those have changed dramatically once AI came out. So yeah, like many of you are mentioning the national CTF challenges and things like that. Those are fantastic, and I do those as well. And a hackathon, it's really less cybersecurity focused per se. It's really getting them to understand business ventures and a little bit of entrepreneurship, but it really mixes well with all this cybersecurity talk because bigger and bigger companies are utilizing the AI all for this. And so newer students being able to use this technology can go off and build their own consulting companies or work for themselves to do that kind of thing. That would be a huge push. And so the one we did in the spring, we ended up with about 45 students that went through there. I think we broke everybody up in teams of 5 for that event. So there was a good number of students that were grouped together, and it was a one-day event. So they had to come in. We gave them bounds as to what we would want it to look like. So here we're in Western Kansas. We wanted them to come up with some kind of app or concept that would be applicable to rural Western Kansas, or a business opportunity or something like that. And then the idea is that they would utilize AI to gain leverage and actually have a working product by the end of the day. Again, literally 8 hours is all they had to work on this. And so it started off with them, again, getting materials, ideas, doing some research. And the idea behind that, just kind of show a little bit of what that interface would look like. So as a student or a team would come in, they would gain access to a Docker instance that had Claude Code all set up for them. And then they could chat with an AI bot that we had built in the background that was really focused on the hackathon itself. So it had some constraints around it. And this was all using local hardware. So we had some laptops in a classroom we wired together, and I'll show you a little bit of the back end infrastructure. But it's really relevant to what we're doing here because they had to understand the concepts we're about to go through in terms of tokens and bringing things in because the students helped build some of this out, at least in the conceptual stage. And then I kind of took it over from that piece. But they would build out a concept or idea, and then they would go ahead and code everything on the left. They would have the ability to go ahead and preview that app. And then at the end, they were able to generate images. So we put in a bunch of different generators, whether it was audio or images or video, where they could kind of put this project together and build a real simple website to explain what it was. And we were, quite frankly, as a staff, amazed at how well these students did for only 8 hours. They had some really rock solid projects that, quite frankly, I was ready to invest in one of those. And I did work with them later on in my software company to kind of see if we could take it to the next step and a little bit further. And this is kind of where I see a lot of schools going here in the next year, is explaining to them how to take these concepts, because this would be directly applicable on the cybersecurity side, which is what I'm going to do here this fall with my cybersecurity students, is this same concept, but now I want you to do this for a cybersecurity theme. So I want you to write tools or come up with a business opportunity that would fit in the realm of cybersecurity. And then this software is, I now have it all whitelisted and labeled. So if anybody's looking at utilizing that, I do year licenses, or I can work with you on different licenses on how to do that. We would host it. All you have to do is come up with your Claude Code keys. And we can share those out across multiple sessions, that kind of stuff. So if somebody's interested in that, let us know. But this should be a good way for people to pull that in. Like I said, on the back end administrative side, we had a bunch of these P16 laptops that ran all the local chat. And then we also used the Claude Code, but we can plug in any version of AI that you want to run it under the hood. So the reason I bring that up is they have to be very good at that prompt engineering. And students are really good at interacting with these LLMs because it's all natural language. And in the old days of dealing with some of the machine learning and that kind of stuff, you worked with more of the discriminative side of things, where now we're working with more generative on this side. So LLM versus the SLM. We're going to kind of look through like one shot, multi-shot, chain of thought, or even system and user roles. And this is really when you start playing with what a LLM is under the hood. This is probably the best thing for you and students to work with, is changing that system prompt, changing that user role. I'm sure you or your students have gone in and worked with even ChatGPT and kind of changed its system prompt, so to speak, that you are a blah, and here is your knowledge. I want you to respond as if you are this person. You are essentially changing that system prompt and changing the way it generates that content to come back and talk to you. One of the main things we'll do at the end of the day is build a simple RAG, and we'll explain what a RAG pipeline is. And we're going to use a local LLM model for that and a little bit of a vector store. This is a great way for you to take a small model. This could be a 1.5 billion parameter or a 3 billion parameter. We'll talk about those details. But that means they're very small. They can run on a laptop. A lot of times these things can run on cell phones and really lightweight devices because they don't need a whole lot of GPU. But you can take that base model and then feed it information that is relevant for what you're wanting to do. And that's what RAG is all about. So one of the concepts I had in the Cybersecurity Institute is we would be able to go out and do penetration audits and things like that with businesses. But obviously, they never wanted their data leaving the network, right? So going in there with something like Claude or ChatGPT or any of those would never work because we'd be releasing their data out to the network, even though they quote won't share it, this and that. You can't do that. So running some local models to be able to run through those systems is a better way of doing it, even if it's asking questions. But then we can take it one step further, and a lot of people will want to train that model. So we'll take that base model, and then they want to retrain it with all the information so that it's focused on their knowledge and not just general knowledge. The problem with that is it's extremely expensive to do. And it's very time consuming and quite frankly complicated to get it, quote, retrained. As a shortcut to that, you can use RAG, and that's why we're going to do that here today. RAG is a way for you to augment the information that comes back based off storing information that you give it. So this could be a series of PDF documents with a bunch of manuals or instructions, or maybe emails coming through, just something that you want to train the system on. And then we do a lightweight vector store on that so that when it does a lookup, it doesn't necessarily go back into its memory or the base of those billion parameters. It's looking first at whether or not we have an answer already readily available. And if we don't, then go ahead and interpret how it comes back. And that's, again, one of the big labs we'll go through here today. And then just kind of, what kind of shared vocabulary do we have between AI and the cyber domains? Everything we're going to do is going to run locally other than you guys in the cloud. And in the cloud, those aren't GPU instances. Those are very somewhat cheap CPU instances that we're pulling out there. So no data really leaves. It's privacy by the architecture. This is what a lot of companies are going to start shifting to. You could utilize things like Claude Code or Claude itself or ChatGPT, but they really don't want their information leaving the network. And so you can switch out those backends. Claude Code allows you to use third-party backends there, so you can use a local one. And we've done this in a couple companies where we'll set up some really good AI hardware and then just redirect everything local. If it's just doing common questions or concerns, that kind of thing, then it can shift and go pull that information out off of maybe regular Claude subscription using a Haiku or Sonnet or whatever model they're wanting to use under the hood, and then switch back to the local one when they're actually executing anything with real data. And that has increasingly become popular with companies that want to save data in-house. We have a similar posture and kind of recommend that for the low trust kind of classroom AI tools. That's the benefit of this, is we're not paying for a bunch of tokens. It's going to be a little bit slower, and you guys are going to see that here today. I believe we're in the about 13 to 20-ish tokens per second. So it takes a little bit to come, but it's still going to be faster than you can read it. So it's still going to be spitting it out much faster than you can normally absorb that. But there is some delay there. Trying to build something, if you guys have ever done that competes with like a Claude instance or a ChatGPT style instance, it's extremely hard to do. There's good ones out there that will get you close, but you have to start paying thousands of dollars in hardware in order to even come close to what that is. And at the end of the day, consumer wise, you could spend up to 8 to 10 grand and still not get close to what you need to run some of those big models. The Docker images we're going to use, their exact bit shows you how to run it. We're going to step through there. So AI as a whole has kind of become this umbrella. It's a place for today's tools, and we zoom in. So we've got rule-based kind of symbolic AI, which is explicit human written knowledge. And then we have our classic machine learning, and those models are going to learn patterns from labeled data. We also have deep learning, which is neural networks with many layers. And then what we're all used to is our generative AI, where models are going to produce new content from what you give them. And these LLMs are the generative text branch that we're using. So some of you may have generated images with ChatGPT for whatever reason. My wife loves this. She takes a picture of the house, tells it to change the color. Next thing I know, my bank account's draining because we're remodeling everything. It's great. It's given her a great way of getting a preview of what things look like early. But it's definitely becoming more and more used. I can get my 6-year-old father to do the same thing now when he's doing something technical. He'll take a picture of it. What would this do, or how would this change it, and be able to pull that information in quick. So the deep learning and the neural networks, or the classic machine learning, this is kind of what we've seen in the past, especially in the cybersecurity realm. So some of you mentioned things like Suricata, or building this SOC out that would analyze logs and that. In the old days, that's really all we had, was this machine learning way of doing that, or even some deep learning where we could have multiple neural networks to kind of sift through those logs. Now we can even be able to use generative AIs because they can iterate much faster and pull in more context. When we start talking about AI and that, the sheer volume of context really dictates how useful the program is. And that, in terms of hardware, that's where you're going to need GPUs and more video RAM, VRAM, that kind of thing. Because if you can't have enough context, you can have the best AI in the world. But if you can't hold enough content to make it useful, it really starts to fall on its face. And that's why you see these frontier models, like with Claude and with OpenAI and ChatGPT, they're pushing that million tokens of context, which is a very vast context. It allows that conversation to go pretty long. Some of you may have seen this if you have a long running, say, ChatGPT session. And all of a sudden, it really starts forgetting what you were talking about. It starts going off on weird tangents, code that doesn't make sense. More than likely, your context filled, and now it has no way of keeping that memory inside there. And they really start to fall apart when that happens. And so that million token context has kind of opened that door up a little bit where you can go for a little bit longer. And then things like Claude Code are spinning up agents. And that's kind of the new topics that we'll cover here later is being able to spin up agents to go off and do this with fresh context, which allows that each session to have its own context and be much, much more efficient. And that agentic driven AI is really the big change. That's how I was even able to run a software company, because essentially under the hood, there's about 30 employees. And there's not. It's me and another guy. And the reason that works is because we have these trained agents of everything job skill wise that we've done in that particular venue. We dump that in there, we train them to be in that fashion, and then we can hand off tasks to those individual agents that are just designed for those individual needs. So whether that's front end, back end, our ops center, chewing through our logs, diagnosing things that we've done in the past, I can have a team of 30 people working with me directly and having an orchestrator in the middle. I can tell you, back in December, I had pushed a little over 1 million lines of code that I was using before Claude Code came in with essentially the ChatGPT style of doing things. And I know people in the class like Terry and those that were in those workshops, we were getting great, vast velocity in writing some of those tools. And then that all kind of changed when this other stuff moved around. I can't say that I've actually written a solid line of code now in almost 6 months. I've edited a ton of code that come through there and look through there. But because I focused all my time and energy on some of these backend agents, they can really do good code. It's secure code. And training students to do that is kind of the main future here. But all of that is based off this generative AI side. So in this symbolic or rule-based one, we kind of had, explicit human written knowledge, if this, then that, decision trees that kind of wrote out. They were deterministic, auditable, but very brittle. Anything breaks on a rule that you didn't have. And a lot of this is what you would get, again, with your Suricata or your SOC type setups, where if this looks like this traffic, then do this. It was more of a machine learning type aspect. And those models will tend to learn patterns over time. So you have labeled data. So whether you're looking through packet type data, from Wireshark or PCAP style data, was a great way to actually get started in machine learning. You could use some Python scripts to play a little bit with this. And there was a classic security. So us building out spam filters or scoring things on fraud, like what you guys see in your Gmail accounts or your Outlook accounts. This is how that kind of standard machine learning worked. It was still relatively small. It's cheap and it's explainable compared to deep learning, but it's pretty primitive and it works significantly faster than what any human could pull in just by learning these patterns over time. And so deep learning kind of shifted that a little bit. That allowed us to use multiple neural networks that have many layers. This is kind of the basic on the foundation now of what we have for modern language and vision models. And it learns based off its internal features. It's powerful, but far less inspectable. We can't really dive into the rules aspect because they're not really there. It's building its own tie. And that's where, if you've ever tried to build an AI model, has anybody ever played with actually creating an AI model from scratch? It's very hard to do, but I was curious if anybody had gone down that path yet. Okay. And so yeah, exactly. Yeah, Network Chuck's great at doing that. It's interesting to do. I would say that at some point you should do that just at a very basic thing. And if you need some labs, we're going to do a couple of things that will walk you through that. But it shows you what all goes into a model. So if you see all these out there on the internet, and we'll talk about that, you have these 1.3 billion parameter models. That means I have to collect 1.3 billion pieces of information to train that model on that setup. And it has to be in a very specific format. It's not really human readable or what you think it would map back and forth. It's all token based, and we'll talk about tokens and how that looks. So building one from scratch these days is kind of out. Everybody's chasing to have the best model. Realistically, what people do now is they take some really good open source models and then you can tweak it, either retraining it or maybe you tweak it by adding RAG and some other things in front of it, like we're going to do at the end. But as John mentioned there, it takes lots of VRAM. It takes a lot of resources to train a model from scratch. And quite frankly, by the time you're done training it, it's probably obsolete because some of these frontiers are using significantly more resources to build it. So being able to interact with the ones that are out there today or doing things like RAG make it far more powerful than trying to write your own from scratch now. I think we're past that hump of being able to write your own. So in the generative AI, these are all models that produce something. So whether it's text or code or images, video, audio, those kind of things, these large language models are largely generative text in what we're doing. And you can utilize these generative text ones to build the kind of prompts that you would need to build good code and images-based ones. That's probably the hardest thing is prompt engineering. And I think many of you had mentioned that in your skill sets is trying to just truly understand prompt engineering. How do you ask the question? It's one thing to let it interpret it as human language, but if you can prompt it in the right way, you can save yourself a lot of time. And a lot of what I try to explain to students and even customers that are going through there is you want to talk to it like a human, but you want to give them the most amount of context as possible so that they can make the best decisions. If you're asking it questions, it can only work off the data it has. And so if you give it bad data, it's going to give you bad data out. That saying's been around for a while, but it's never been more true with AI. You know, it's only going to be as smart as what it can do. Now, it can draw some pretty good conclusions across some things, but you definitely have to know how to prompt that. Yeah, and I agree, Terry. That's a lot of companies that are hiring students and they come back, they're telling me learning how to prompt is the biggest piece of the whole thing. And getting this in the hands of students now and they'll start to understand it, it's a lot better. Now, when we were getting garbage out from the early AIs, that wasn't necessarily meant that we were putting garbage in. It just meant we didn't have the resources sometimes to hold it all in context so that it could respin it back. A lot of times it was still bad data. Nowadays, the bad data side is kind of dying other than what we're feeding it for context information. So, and yes, this is kind of the new thing now is because all these are more advanced and have more capabilities and more, I would call it general knowledge, which is really what all the massive companies are out there for. They're in order to win, so to speak, with the air quotes here, for Claude or for basically Anthropic or OpenAI to quote win, they're all looking for this general AI knowledge. And if they can hit that, that is the end goal, because at that point, the AI is smart enough across so many different domains that it can start to program itself. And that's the reason last fall that we started to see Claude Code and this aspect where the coding side of it got really, really good is now we can kind of train it to code itself. And once it gets past that hurdle, then it can start to take out all the other pieces that are hard to accomplish and get us to that general AI knowledge. But that gives us a pretty good attack surface. And I ran into this many times, you know, building these AI tools for small businesses and such means there's always going to be that student, that person out there that likes to push the limits. And that's why I love working with students. They're going to use it for a totally different reason. A great example was this AI hackathon. They wanted to see, well, how bad did I restrict it? You know, can they still get data out that they were, you know, what are the guardrails they put on this thing? And it's a great way to test it, but that means we have that attack surface. And if you can give it to give information out it's not supposed to, that is where we got to try to manage some of that risk and get those guardrails up. So in the security world, a discriminative model is going to be something like which class is this, which, for example, will be a prompt injection. And we'll kind of meet on that. In other words, does this match this style or this style? Yeah, that was kind of the issue with Fable when it came out, is it had the guardrails, but Fable, if you've ever tried to use that, it's scary. It's scary because it's a next gen shift like it was back in November. We've had multiple big jumps since November, December, really January when things were kicking off hard. Every couple months, it would just take a leap in through there. Fable is one of those. I used it in my more recent software, doing the exact same thing I was doing with Opus and Sonnet. Fable allowed me to unlock a 40x multiplier. I could get 40 times the amount of work done that I was doing on Opus in the same amount of time. So a great example was with that client, I said, look, this is going to take about 2 to 3 months in order for me to get this through. And that's with AI. Before that, it would have been a year. It was a massive project. Fable came along and I was able to knock out the core while Fable was free there for a little while. I knocked out that core in less than about 2 weeks. And that was something that gave us a massive jump so that we could get further down the line. It's good at what it does for certain things, and it's really just the architecture and the execution of things. Fable's good there. The newer version of Codex that's out there was a great complement to that. And then when you start getting those two working together, and even in an adversarial way, you can start to catch a lot of bugs and issues because every single one of those gets a little custom tailored to themselves. Like Claude wants to use Claude things, and Codex wants to use Codex things. But if you get them to go against each other and then kind of have a third party look at that from the holistic side outside, you can get some really good code out of there, and a lot of secure code. Obviously, you have to run it through the right skill sets. But generative models, what comes next? That's really the LLM side. So you'll often deploy both of these style in order to execute. A generative model will do the work, and a discriminative model will end up trying to guard it. Claude's a great example of that, where if you've tried to do things now that you got away with in the past, it won't let you do it. And that's because they're starting to get more of these discriminative models in front, making sure that you're doing this in a secure fashion, making sure that that type of question is protected. I used to use frameworks like GSD and that kind of stuff on top of Claude in order to give me some guardrails and some security and some security or software development best practices. And now all that kind of stuff is baked into Claude. But what I've noticed is you have things like auto mode on, and this little discriminative model will make sure that it's not changing a bunch of stuff in a database unless you're telling it you want to, which is good. Those are the kind of things they're putting in for people that don't understand that. From an ops perspective, and I'll kind of show you how I use all this in an ops perspective. It's really, really good. You can get your guardrails up, protect it the way you want, protect your API keys and the things that you were probably saving in clear text files and whatnot. There's good systems to do that. And if anybody's ever written code and used, environment variables and that kind of thing, especially when you're doing it in an ops fashion, it's very easy to leak those keys out and not think about it until later. And then you can start hashing through somebody's logs and pulling those kind of things out real fast. So just kind of a quick check to make sure we understand these different model types. A classifier that labels incoming prompts as an injection attempt or benign before they reach your chatbot is best described as A, B, C, or D here. Anybody got any thoughts? Yeah, B, right? So the whole idea is we're going to take in that prompt. We're going to make sure that what they're asking us isn't an injection attempt or is it benign, it's a true question. And that categorization is going to help protect our chatbot from giving out other stuff. Now, in this case, we're talking about a chatbot, but it's really a real fast process that's really in the generation where a lot of you will run into this. And I know I'm going to, forgive me, Terry, I may use your name a couple times here, but when Terry and I were building some stuff last fall, we saw this same thing where you couldn't get it to write broken websites, or we couldn't get it to write broken cybersecurity things that we were training on the CTFs because it just blocked it. It would hit these discriminators, and we would have to explain to it, no, we're trying to do this for the classroom, and we're trying to build, vulnerable packets or show there was vulnerabilities here. So for those of you guys with cybersecurity clubs and wanting to build out this kind of stuff, we do have some resources I'm happy to hand out on that kind of thing. because it's tough. You have to retrain, and that's where using your local models and taking down some of the guardrails is great. You can still get by with that. If you try to use the over-the-counter ones, it's very hard to get that to work sometimes. So yeah, B is a good answer here. Again, a distributive model is going to answer which class this actually is, and then we can kind of go on from there and get our prompt back out of it. So on a large language model, these are your frontier scan, and these have hundreds of billions of parameters. I talked about the 1.5, the 3 billion parameters. Your frontier models, they're dealing in hundreds of billion parameters, and some of them are getting even higher than that now. They have a very broad reasoning and a recall, and they take some serious hardware to run. This isn't something you could even light up in your data center at your institution. It requires some really big hardware to run. Small language models run in that 1 to 3 billion parameters. A very popular one that we're going to play with here is Quinn 2.5 at a 1.5 billion parameter. And that one fits right in your laptop RAM. It runs on a CPU. You don't have to have a GPU to do that. That one's also a good one. If you run it at a 0.3 billion parameter, you can run it on a cell phone really easily. So the good news is you can have multiple of those running on a very basic hardware, and it's good for the classroom. It teaches them a good core concept. The one that we were talking about even over here when the students were doing their AI hackathon, you could see we were using the 3.5 billion, 3.5 model, their 9 billion parameter, runs really good in a 16 gig of VRAM or laptop. So very easy to use some of these smaller models. Both of those are going to be decoder-only transformers, which means the architecture is the same, but the scale is not. So the concepts under the hood between the really big parameter ones and the small ones are exactly, they're just operating at a much different scale. And how much of that extra VRAM you can give them for context, I can have a really big, really nice model, but if it doesn't have enough context, it doesn't even have enough playroom to actually work. It's like driving a semi in a parking lot at McDonald's. Like, just you don't have enough room to work. That tool is capable of doing a lot, but not if its sandbox isn't big enough to actually move around in. And so those trade-offs between your SLMs and your LLMs, SLMs will give up a little bit of reasoning, a little bit of world knowledge. In other words, it's not that all-encompassing knowledge. I can't ask it a law question and then turn around and ask it a medical question. And we give that up for a little bit of portability and privacy. We can train it on the things that really matter to us. And if we're not training it, we can use RAG and other tools in order to pull off the same end goal of its knowledge. So the main reason that we're using the small models in this workshop, really that Quinn 2.5, the 1.5 billion parameter is a workhorse. Because it's fast enough on CPU for some interactive labs. It makes the student feel like they're actually interacting with someone, even if that someone isn't the brightest LLM that's out there, so to speak. The 3.5, or I'm sorry, the 3 billion parameter one we'll use on day 4 is really for tool calling, and that's because it needs more capability. So if you're looking to replace Claude Code or Codex, that kind of thing, you got to run a little bit bigger parameter one. Even 3 is really small, but 2.5 seems to be okay. But you need the context to go along with that for tool calling. And tool calling is what you do when you're actually doing coding under the hood. You may need to have different skill sets, for example, Bash scripting or Python scripting. And we'll talk about how skills are interlaid within there. But you got to have the tool calling aspect in order to do that. Everything in here, your Nomic embedded text, this is how we're going to do embedding behind that. And that's really the best thing for RAG. It's a very small model and allows you to take things like PDF documents, strip down some of the words so it's very fast and easy to look up. And then it embeds those with page numbers and things like that so we can do lookups on the fly. So it looks like it's thinking a little bit longer, but it's able to narrow it down to a PDF, go look up the information out of, say, a PDF, and then pull that knowledge back to you. Some other core vocabulary terms, your model, your training, your inference. So a model is just an artifact. It's an architecture plus all the learned weights that come through there. Our training, that's that expensive piece, and we typically do that offline. This is a process from which those we set those weights from the data itself. This requires very large data sets in order to do that, and they have to be very detailed. A lot of times you can go out and get access to some data sets. That's probably the best way to play with, quote, training your own model, is to go grab some existing data sets. I once tried to build a data set. For example, I teach an advanced Python class, and I wanted to download all of the documentation for Django, which is one of the frameworks that I used to teach in that class, and just build it as a data set so that I could train the model to answer any Django questions. It'd be like a chat bot, but it was very tailored to the documentation. Student could ask a question, it would point him to the documentation, show him right where to go. That little process took me about a week, and it would have cost a couple $100 and actually taking that data set to retrain it. And that's because it's very, very costly to do that. It takes a lot of RAM, a lot of time resources. However, I was able to accomplish the same thing with RAG, which is what we're going to do here today, because that data was changing all the time, that it could look up in real time where that information was. Once I trained that model, if they changed something in the documentation, you'd have to turn around and retrain the whole thing all over again. So it's good with base knowledge, but not good with things like documentation that may change. And then inference. And inference is using that trained model to produce some kind of output. And that's all we're going to do this week, is really deal with inference. That's you typing on a prompt. That's you interacting with it to get something back out of it. That's really the core of what we're trying to do here. Nothing's going to actually retrain this model. It will have more knowledge of what we wanted to have more knowledge of, but it won't actually fully retrain the model. So how do these LLMs actually work? They're all based off transformers. And these three ideas are enough to reason with them. We have things like tokens, and these are the unit that the model reads and writes. You can think of these as block of text. There's usually chunks of that text, and there's not a great discriminator. There's lots of tokenizers out there you can go look up. So if you look up, let's do a Google search here for tokenizer. This is a great way to see how this works. If I say, hello, class, how are you? Whoops. We can see that it broke that up into 5 tokens. So if I sent this off to my model, this hello comes in, this space class is another one, but it broke up these each ones. And while there is a rhyme or reason to it, you can typically think of a word as a token. However, if you have really long words, that may be spread up there. And each model will tokenize that sometimes a little bit differently, depending on how it's coming through. So if I did this example here, we can see where it breaks it out into 53 tokens. And we can see that in ChatGPT 4, that would have been 57 tokens. And in 3, it'd have been up to 64. So these token sizes get a little bigger, which means we have to have less tokens as we go through. But when you talk with these different models, they all want to talk in terms of tokens. So when we interact with a chat, it's how many tokens can it generate per second? Makes it feel like how fast is this model sending information back to us. So if it generates 5 tokens a second, and this is 53 tokens, you can do some math. It would take 11 seconds possibly to generate this information back to us and then spit it out on the screen. Your frontier models are working in hundreds of tokens per second, if not faster in some cases. Once you hit that threshold of about 15 to 20, you start to feel like you're talking with somebody almost naturally. It can generate it faster than you can read it. However, the faster it gets beyond that, then it just feels like it's really, really snappy. Then you have your embeddings, and these are kind of the meanings that wrap the vectors to the numbers. These vectors are, again, are little chunks of data that we're storing in a database and then matching them out so that we can easily read those out. And how a model will use this context is kind of produce 1 token at a time, kind of what I was saying before. And the speed at which it does that is the speed we interpret as to how fast that model is. So text is chopped up into little subword tokens, and a model will read and write those tokens, not the actual characters themselves. Cybersecurity might end up being up to 3 or 4 tokens. So if we actually put the word cybersecurity in here, in this case, it chopped it up into 3 tokens. In some older models, I know for sure it was up to 4 tokens, depending on what was in there. Common words are usually a single token. And model prices, their limits, their behaviors are all denominated based in tokens. So if we were to look at Claude, for example, you will have Sonnet. Everything's measured in 1 million tokens in and 1 million tokens out. And that's how much you pay for that kind of access. We talked about Fable. That was some pretty costly one if you were to do that all in AI or API tokens. However, you can get a lot out of those tokens if you organize that correctly. And so cleaning up your input and output, every time we use a tool, every time it calls something under the hood, it's going to use those tokens in order to do that. And it's filling that up with its context, which is the next piece here. So you have your context window, and that is the maximum number of tokens that a model can attend to at once. Everything, the system prompt, our user input, any documents we retrieve, any prior conversation history that we've had must fit inside that context window. And nothing outside that window exists as far as the model is concerned. Some of these have the capability of having multiple context windows to pull from, or very organized context windows where it can kind of collapse it down over time. But you can think of it as its brain. We can only put so many things in that brain. It has that long-term memory. This is kind of its short-term memory, if we were to equate it. And once that fills up, it starts dropping thoughts and processes real quick. Basically, all of us before a cup of coffee. Those embeddings are going to be tied to every token. So separately, every chunk of a document is going to get mapped out to a vector of numbers, and then it tries to capture that meaning and correlate that meaning. Similar meanings are going to sit closer together in this vector space. And so questions like reset my password or credential recovery will land near each other despite they're not sharing any words. They have that familiarity, and we're capturing that and keeping those closer together. That's really what makes RAG similar to a similarity search possible. So if we want to search through a bunch of PDF documents, say, give me a listing of all the PDFs that had this word in it or talks about this concept, it will scrape all of that into a vector database. Those similarities get closest to each other and then can mark those back out to those. So it's really cool in a way to do this in a very speedy way. The great part is we can do this on our laptops. So in the early days, this was kind of hard to do, but it's kind of fun now to put it out, and we'll do it here in our lab today. Attention. So self-attention lets each token weigh every other token inside the context. This gives the model the ability to learn which parts of the context matter for predicting the next token that we come out. And this is the mechanism that makes in-context learning happen, or a few-shot programming, meaning if our context window is big enough, we can just load everything up into there and then start asking questions. Some of you may have done this with something like ChatGPT, where you take a PDF document, you upload it. This could be a research article. That's probably the #1 use case it used to be great at. Load up a research article, ask questions about the research article, and it could pull that out because it loaded that whole thing into its context window. If you're trying to do this over multiple PDFs, obviously that starts to die because the context window just wasn't big enough for that. When I was going through my PhD program and some things, this was a great way to get some of that information out of an article. We would still have to scan it and pull everything out, but we could draw correlations between PDFs that would take so much time to do outside wise that we could then go back and figure out, okay, either this is good data or not, and weed out that research really quickly. That was probably my first foray into ChatGPT was in the midst of the PhD program, and being able to tie research from one place to another and figure out whether this research article was even remotely close. Then I could go back and authorize and pull the data I was really curious about. Some auto regressive generation. This model generates exactly one token at a time, and each token is then fed back to its input for the next prediction as it comes out. So that output is a probabilistic continuation of everything currently within the window. In other words, here's what I expect that you would probably want back out of this question. And that loop is kind of a prompt content, including the injected content we went in there. So it strongly steers the output. The idea is it's going to give us better output over time because we're generating one token, kind of confirming it, checking it in a loop, and then spitting it back out. Then we kind of throw in this security lens, which is all these stream of tokens as it come in, because as a model treats the entire context window as one stream of tokens, it can't inherently distinguish between trusted instructions from untrusted data. And this is where I've seen a lot of students get themselves into trouble in the early days, is they would have the system prompt in there, the questions that they asked, all the documents retrieved into the tokens, and then that single root prompt, as we're going to do here in an injection, we could pull out all the context. We would fill that window, crash the system, it would restart, and we could just start with a clean slate and start pulling context out. If it doesn't have the guardrails, you could get it to dump environment variables really fast. Right, even in ChatGPT, you could do that before they got more and more of those guardrails up. So we're going to check our context window. One kind of question here that's coming up is we're approaching lunchtime here within about 10 minutes. So I wanted to get through a good chunk of these slides. We'll have some slides in context, but I want hands-on the rest of the day here. So what can a document retrieved into an LLM's context steer the model's behavior just like a user instruction can? Anybody have any idea what that would be?
I would guess B.
Yeah. Yep. Again, the idea here is we're not really writing to a vector database yet. We're just purely able to take the entire content of what they're putting in that document, translate it to tokens, load it all up into context, and then we have no way of distinguishing between those instructions and data. It's just a stream of context tokens coming through there. So that transformer is going to attend over everything in that context window equally. It will pull out the retrieved chunks, and architectural fact is the root cause of both direct and indirect prompt injection. Because we loaded that up, it's not going out to go look at the PDF. Everything's just right there in that forefront knowledge. So prompt engineering, many of you have talked about this as we've gone through here. It's the idea of being able to program without actually training. It's how you prompt or how you interact with these systems to bring that in without retraining them. And so the prompt is your interface. It's your instructions, your examples that you give it, any kind of outside context, tell it big picture that you're looking for, or if you have it set up in roles. In other words, I will set up a model, and you guys will do that here too, of you are a customer service representative. So a great example on this AI one that I was showing you guys earlier from the hackathon is the system prompt here is you are a chatbot for a hackathon project. Only give them information that they would want to use about this project. Do not allow them to ask questions outside of that. And we have things like web search and things like that turned on where they could get it, but we only wanted them to answer here. And a lot of that was because of this context window. With the amount of VRAM that we had, we could eventually bump this to 98K. But in the early days, you were lucky to get 6,000 tokens in a window, maybe 12,000, 20,000 if you were super lucky. It was really hard to give it a very big context window. So a small prompt can change the behavior of large, or can produce large behavior changes and treat prompts like code. So you have to be very clear and concise in what you type. If you dump a whole bunch of code in there, it could try to execute it versus interpreting it as tokens and text. So interacting with LLMs is probably the single best thing you can do for yourself and with your students, is getting them to understand how to copy and paste things in, do it in block style format. Giving it a question before you give it some context and then follow up with that right afterwards. All in the same block. If you try to break it out over multiple little pieces, you start to fill up that window, because now you have your input tokens and your output tokens filling up that context window so it knows what it talked about before. The more clean and concise you can give a prompt, you take up less of that context window, which means before it fills up and starts losing its memory. Now, most frontier models and those all have ways around that now. It's literally called memory, where it's a bunch of markdown files that it can load up at runtime, basically RAG, and be able to learn where it was or what it's been talking about or the context of whatever you've been working on. so that you actually have this idea of a file-based memory that you can load it up. And I always chuckle because it's like skills when we talk about those. It's really the Matrix. You are loading up a file, and now all of a sudden you know Kung Fu. It's the idea behind the skill sets in some of these frontier models is you can write out these skill sets, and once it's stored as a file, you load it up, and now it has that new skill set. And that's really I'll kind of show you under the hood of that ops side of the things. Once you build up enough of those, now it can operate as a artificial intelligence and actually figure out through those skill sets what you're wanting it to do. And people trade these skill sets online left and right. You can download them. You can use whoever's you want. You can build your own. And that's probably the best part of most AIs is you can build your own skill sets because then they're tailored to what you're doing with your particular instance. And you can trust them a little bit more when you go through there. So in zero-shot prompting, this would be an instruction with no real examples. It would just say, classify this ticket's urgency, right? So we submit a PDF. What is this particular ticket's urgency? It's fast to write it. The quality depends entirely on what the model already knows about the subject or whatever you're feeding it. It's often inconsistent in the format and the edge cases. It's really good for small models because it's only going to give you quick information in, quick information out. The more prompt that you give it here and the more styled it is, the better the chances the information you get back from it is good. Today, it can do a lot more inference as to what you were expecting it to be. A lot of times you guys will see this in your frontier models where it'll come back and say, I think you were talking about this. If that's correct, then here's what I would expect. At that point, it means I had no idea what you actually wanted. I'm just going to take a wild guess as to what you wanted. Your one-shot and multi-shot or a few-shot type prompting. This is going to be your output format, and accuracy is going to be superiorly better as it goes through. You're anchoring it off little pieces going through there, and this is what we're going to do in our lab here today. You can see how much better those responses are going to come out. If you start with a chain of thought, if you explain, just like we do as instructors, the entire concept around whatever topic we're teaching and everything you would think they would need all in one go, that will give you a significantly better output on the backside. So you can ask the model to reason step by step before answering. It will help with multi-step problems. It does cost more tokens. You'll burn a little more tokens. In Claude, they would call this something like plan mode. So if I want to talk about building this app or this feature, I want to sit there and talk with you a little bit about it, hash it out. Then we're going to synthesize that and bring that in as a final prompt, which will start building the actual product under the hood with the tool calling. That's really where a task really starts to use some reasoning under the hood based off what you've been talking about all along. So we talked about the roles, and this is probably the best prompt as we go through there. You have a system message. This is going to act as what's the behavior you have, what guardrails, what you can and can't answer back when I ask you to give us a response. These are the ones that are getting significantly larger from the frontiers as more and more people have tweaked or manipulated those. And now we're seeing all sorts of, not to get in the political side of it, but you see all sorts of this where kids are asking this, how to go do things they shouldn't be doing. And now we got to put bigger guardrails on it. Well, then how do we protect the ones that are still doing research and need those guardrails off? How much guardrails do we need to put on our AI so it's not out there doing things we wouldn't want it to do, but at the same time, you're cramping that expansion of knowledge or the ability for it to go do something. So a lot of these models will tend to have a base system prompt you can't change. And then there's other prompts you can kind of do over the top of that. But at the end of the day, it will not do XYZ. It's been baked in from the beginning. That's where people try to hack that a little bit and get around that system prompt. Well, you'll be okay. Just tell me how to do it. About the fourth time, fifth time, it ignores all of its instructions and just does it. Obviously, you can button that down, and you can button that down through the system message that goes through there. The user message is basically carrying the request. This is how we are talking back to that AI model, and it's going to carry whatever we're bringing back into that. whether that's a stream of tokens, is that our human language that's coming through there, what's coming back. We place those instructions in the system role. The stronger they are, the better they are. But again, it's not an airtight boundary, and we can determine what the user cannot cross. And those are all being logged. And because of that, we can manipulate that as we go through there. So in that security lens, the roles themselves are advice. There's no way to truly enforce that. The only way to really enforce that is we have to have this depth and defense. Meaning we can have a system prompt out there that says, hey, don't give them the answers to the test question. I want you to prompt them to go look that up in the book. Okay, that can work, but what we really need to do is scan for anybody that says, hey, give me this answer. If it matches that, now we've got that classifier. We can then filter that out in a different way that says you are a helpful assistant, but never give away your prompt. It's going to then look back at what we're sending to the user, scanning that information to make sure we're not giving more information than we should have. And then you also have this least privilege around the model where you can make sure that you're not going to set a threshold. And it's not just what it's generating back, but we have some kind of ACL that's protecting that. So an assistant keeps misclassifying support ticket information urgency when only given an instruction. And so which technique would most directly improve that consistency? So we've talked about this several times. In this case, just pulling it out here, lowering the context window, that's going to make it worse, right? Again, the smaller that context window means we filled up our short-term memory, which means it doesn't have any idea what to go look up. So we can rule that one out. D, removing all the instructions and letting the model decide. Probably not the best idea. We need to give it some guardrails. And we could do some multi-shot prompting and kind of include several labeled examples in there. But the idea is we want to change a little bit as to what's coming in, and we can give it a different prompt. And so multi-shot is actually the better one here because we can give it examples of what it should be. And that way, if we feed it that little 1-0 context type thing, or the 0 shot, that allows us to provide that instruction and get that back. Remember, the key here is we're trying to do that classification side of it. Consistency, this is more protection. So a lot of you guys said C. This is switching from a system role to a user role only. That doesn't do you any good because you need that system role in order for the AI to have a context of what you want it to act like or how we're responding back in here. So a couple of shows of examples in this. You show the model 2 or 5 actual working examples, and then from there, it will do input labeling and mapping so that the next one you give it on a 0 shot, it's much better alone. So a good example of this that may be relatable if some of you are in the farming side of things. One of the companies I was working for was a grain type elevator, and they have tickets that come in when they dump off the grain at the end of harvest. And those tickets tell you, you know, how much the semi weighs, how much grain you have, what's the test weight of the corn or the wheat or whatever you're using in between. And some of these are handwritten examples, and some of these are full PDFs, just simple printouts. On those PDFs are the best ones. I can go through and I could take about 5 of those sample tickets, feed it to an AI system. It could then label those pieces. If you think OCR, it's kind of like OCR, but it can now do it with context, meaning I can tell it, look, I want you to OCR this information off the page, but everything that's in this upper left is where you would expect to get the test weights, instead of it having to filter out a paragraph text and try to find those things out of there. OCR works, it just gives it as a stream of text, where a vision model or an AI prompt like this can take several of those examples and learn over time where it's kind of labeled, and then it will pull that information right back out of it. So that's kind of a real world example of a multi-shot, or give it a few examples in order to go through. You can do too much. So this could be like, in some cases, I would feed it 100 ticket examples and think, man, it's got to be better now. It's got 100 pieces of information to pull through. Well, what's the problem if I feed it 100 tickets? Kind of goes back to some of this stuff that we see in these answers here. Yeah, context window, right, Marla? So it was great that I gave it that many examples, but I filled my context window so that if I ended up giving it one more example, well, now my context window's full and it almost goes back and reverts to having no knowledge because that context window will max it out. So giving too much can definitely be hurtful in there. You want some real clean cut examples, and that can give you a much better consistency over time. Now, at the same time, you sometimes want to feed it bad data so it knows what to recognize as bad data too. Or the best way to do this, you guys may have seen this on your ChatGPT prompts, right? You have a thumbs up, thumbs down. So if it gave you a bad response, you give it a thumbs down. That tells the AI something was bad in that particular response. Sometimes you can tell it what was bad. I build this into all the products that I have. If I have an AI chatbot, I need that information back because then I can retrain my system prompt to be better, or I can go build the tool that it needs to give a better answer back out of that. All right, so we're up on the lunch hour, and that's great, kind of a breaking spot because when we get back, we're going to go into much more detail of RAG and why that helps us with our context window. And then we can get some hands-on labs here for the rest of today. So I'm going to pause the recording for this part. Back up. So we left off at RAG. So before we jump deep into RAG, how are you guys doing on timing in terms of the pace and content? Most of the rest of today is going to be more in the hands-on realm. So you guys will have some time to really understand what I've been talking about, not just some keywords and things like that. So, okay, good. Well, like I said, if somebody's off pace or anything else, by all means, message me. I really like to change the workshops to make sure you guys have what you came for, because I know you're spending a whole week for all this. So, and I'll show you a little more on the resources. Good, Chris. There'll be a lot more resources go on that website as we go here, and I'll kind of show you that after we talked about RAG. So RAG, again, is a retrieval augmented generation. The idea behind that is a bare LLM, like we've talked about those models, only know the training data that we gave it. And so if they wanted to adjust that, or you wanted to make that knowledge or that model more capable, you'd have to completely retrain that. And that's very expensive to do. So the idea behind this is that we can use RAG to answer or ground the answers of what we have inside of the documents that we feed it. And like I said, the biggest example or quickest example is what I was talking about with like research articles. And so I believe it's Paul here. Make sure I got your name right. Yeah, Paul. Like Paul mentioned here was Notebook LM. And Notebook LM is a fantastic example of RAG. It's just that. Whatever context you give it, that's all it's going to talk about. It's not going to try to talk about other things outside of it. It focuses just on that. And so I use Notebook LM in the classroom. My students love it. They tend to build their own quiz questions and everything else with my content. So most of the classes I do are all recorded and published out on YouTube. And so they take all my YouTube recordings and a combination of the book materials or whatever else, pump it through Notebook LM. They can ask quiz questions, build out exams. They love the podcast feature that Notebook LM has. So it's a great learning tool for them to take right on top of most of the stuff I do in the classroom. Oops, let me find that real quick here. That one, there we go. There we go. So yeah, Notebook LM is a great example of that. And I'm going to show you some other software tools that you can use on your desktop to kind of describe RAG or get more hands-on with it beyond what we're doing in the labs today. Those can be a little more user-friendly than the labs that we're doing. Most of the labs, the reason I use Docker for all of that is it's reproducible. And so you guys are all IT instructors, or at least in the IT realm. Labs are only as good as you can keep them reproducible, and you're not doing software support or troubleshooting support with 30 students in a classroom. You need it to work every single time. And that's what the Docker labs provide, is they're meant to be a very reproducible setup. However, if you are just demoing some things in class and whatnot, there are other tools that can kind of demo RAG in an easier way. And I'll show you those as we get through here. So if you want to add knowledge to it, you can easily use RAG to do that. It does reduce those hallucinations when the retrieval is good. and it does not require that full retraining process. So the way that works is it's going to ingest something. And so this can be your documents. We're going to break those out into chunks. Those chunks are then going to get embedded. Those will turn each chunk into a quote vector. And you can use a couple different vectoring databases for that, or different vectoring models. I'll show you those actually in a tool here, but the one we use in the lab is called the Nomic Embed Text. This is a pretty common one, very lightweight, easy to use. It will then need to store those vectors. Those vectors are stayed within a database. There's multiple different forms of that database. Chroma is the one that we're going to use in the lab environment. And it does that with a similarity index to try to kind of index everything. And then you're going to retrieve that. And it does that through the embedded user query. So we make a query, it fetches all the embedded chunks that we have up above out of storage, and then we'll fetch all the similar chunks. And from that, generate by injecting those chunks into the prompt, and then the model will answer from that in context. So he gets a little bit of all that information, still has the general knowledge to put everything together and formulate against the question that was asked. So what all lives in that vector store or that vector store? It's just a numeric embedding vector of text chunks. It's used for a similarity search. That query is then embedded to as well. That way the store returns those chunks whose vectors are very similar. This is a similar lookup and a retrieval within RAG. So similarity lookup is probably the most common use inside of RAG. However, they do have some weak points, and if the wrong chunk is fetched, then the model faithfully uses it, meaning there's not a great way of checking it. So making sure you get the right similarities and things in there, or if a poison chunk was fetched, the model will faithfully use that too as well. Just like we've always said in the beginning, garbage in, garbage out. The only difference is garbage in or malice even in, it's going to be try to be confident on its answer out. And you'll notice a lot of these. Hey, John, I bet I do. Let me double check here. Yes, I got you, John. No problem. Most of these newer models even try to say how confident they are. If they're not confident, they're going to actually tell you that. So if you've used, for example, the newest version of Claude Opus and such, it'll tell you, I don't have a great answer for that. Here's what I'm expecting, but I'm going to be truthful with you about XYZ. And I'm noticing that that's kind of a trend across most of the frontier models. For day 2, we're going to cover more of that vector and embedding weakness, and then try to include a direct injection into those documents. So if we feed it bad documents, we can actually poison our AI so that we can pull bad information back out of there. So in that RAG pipeline, what are we using to store that vector database? Anybody remember how that works? Yeah, C's, right? So the idea is that we're going to take that document or whatever we're giving it for our RAG pipeline. We're going to break that up into text chunks, and we're going to embed those vectors, and we're using that for a similarity search as it comes through. All right, so that gets us out to that first lab, and we're going to do that through local Llama and kind of build that little pipeline. So the first experiment is shot prompting. You guys will see what a 0 shot looks like versus a multi-shot. In the second one, you guys will be able to do a little bit of role placement, so play with those user and system instructions. And then the last one there is going to be kind of a chain of thought where you have a multi-step problem and you want it to work through all of that. And we're going to work on ingesting, embedding, storing, retrieving, and kind of generating that with Chroma and that text there. So I'm going to bounce out to the lab. The lab, that'll get over here on day 1. And we've been in these slides. I haven't even talked about this, but this day 1 has this same context we've been talking about in the slides. Just some more information or some more feedback as to what's behind it. So I don't plan on having you reread through all this context or anything like that. It's just going to give some better definitions inside of there. As we were talking about the vectors, it's literally the same thing. I want to make sure I didn't forget anything when we were going through there. With that human in the loop, when we were talking about this life cycle, and we'll get through this past the RAG, is really getting somebody in there so we can do some AI assisted work. And again, RAG is a great introduction to this because that is how we would typically do it now with our PCAP files or Wireshark files or any kind of data that we want our security systems or our SecOps type classes going against. We want to be able to retrieve that stuff out of there. And CVEs, whether it's Wireshark files, like I said, those are great ways to take a basic system or a basic model and ingest information that you want it to be focused on. So if you have Docker and you got everything set up from what we were kind of doing before, you can go ahead and download this zip file. You're welcome to verify the checksum if you choose to do so. You don't have to. Here's how you do that. You just run this command and make sure that you got a good copy coming down. And then inside your Docker container where you pulled this information down. Now, most of you, the easiest way to get this file is if you kind of come in here and just copy this address, and then inside your Docker container, which I'll deploy this the same way you guys are doing, you could go ahead and start this up. So for example, I've downloaded that RAG file that we have here. Just open up a prompt with it. And so we see that zip file. I can go ahead and unzip that. And we have that folder. So just like the instructions say, you can go CD into that folder. If we look inside, you see all the different packages that come with this Docker Compose setup. Again, the beauty of Docker Compose is it's preset, will always work. It's consistent, so it maps to your lab documents that you have out here. So I tend to like to use this for the classroom. You could run this on like a NetLab system. I think somebody asked me that before. You could easily do that. Just have a simple VM running with Docker and then have a folder of all these different Docker images so that you could run through. That's essentially what the cloud version of this is doing. It's just a VM that is running out in the cloud with public IP that some of you needed to get access to. So once we're in, we can just run Docker Compose up -D. What that does is read this Docker Compose file. If you're not familiar with how Docker works, Docker is like a little tiny container, and you build out a single container. By using Docker Compose, if it needed multiple components, it would go ahead and start all those services up and be able to execute that in there. So the idea is we can keep that all together. So I run that, and if I was to watch this in my Docker desktop here shortly, we will see it build out a new VM here. Get rid of some of these old ones out of here so it's easier to know which one's what. All right, so what is going on in the back here? I know, how many of you guys have actually played with Docker, or better yet, how many haven't? And that'll kind of give me an idea of your familiarity with Docker. Okay. Okay. So again, the reason I try to push Docker in the classroom for this is because it is pretty friendly to use, but it's nice, it's lightweight, you can do it on easy hardware, that kind of thing, and it's really meant for consistency. So what we just did here by running that Docker up command is it went out and found an image that was built out for specifically what we're wanting to set up here. In this case, it's like a very basic image. Let me see if I can pull that up here and kind of show you what that looks like. So if we look at this Docker Compose and just a text editor, in this text editor, we can see the container. So it's pulling the Ollama container. Some of you may have played with Ollama. Ollama is a software that allows you to download these large language models and then host them and interact with them in a way. You could have downloaded Ollama directly onto your laptop. So that's how most people start playing with models, is you can do a Google search for Ollama and you can download their little desktop tool. It's very simple to run a command and download a model. And they have tons of models that you can get access to. Those are all the cheap ones that you can host yourself. There's no cost to them. Or if you pay for their online service, you could pull that down too. So some examples of those out here, you can see the Quinn 3.5 family clear down to a 0.8 billion parameter. Real nice and small. It tells you the command on how to install that on your system. This is really common. The only thing that we're not doing in our lab environment is having to set all that up so that it's consistent. But I'll show you some of that. While we're there, if I click on this day one and you scroll down here on these labs, at the very end, it's going to have some alternatives for you to be able to do. So if you didn't want to do Docker and you wanted to show people with some other GUI based ways of doing this, there's anything LLM. We'll talk about that. That's another one that kind of walks you through how to do this stuff. LM Studio is another great one to use on your laptop. So both of those look a little something like this. So here is anything LLM. It looks much like a Chat GPT style interface. So if I go back to the main screen here, I can interact with a model and I could tell it which model I want to use under the hood. So for example, here I came up and said, we're going to use the Quinn 2.5, which is a real lightweight one that most laptops, CPUs can handle. In the lab, we're going to use Quinn 2.5, I believe 3B, which is a little bit smaller yet, runs a little more efficiently. But you can then talk with it and interact with it. So I can say hello, and it's going to spin up that model in the background. It takes a little bit to do that. You'll see your RAM, your computer may speed up a little bit in order to get that loaded up there. But this is what you would do with anything LLM. So this one, LM Studio, is another great one, and I'm going to demo that one here in a little bit. The beauty of things like LM Studio is it lets you really play with that context window, but you can see here while I was interacting with how fast it would operate, give me a 200-word explanation, and it will tell me how many tokens per second, how many tokens it actually took, and when it got to different reasoning. So all these different tools are available in the classroom. This one could be a little more effective if you need a GUI for demoing. Otherwise, our Docker container works fantastic and is much more reproducible and consistent.
Jason, just to confirm, if I have LM Studio, for example, all I would do is run the commands on the LLM. I wouldn't need the Docker file for anything.
Not necessarily, no, because the Docker file is actually mixing more of just that together. So
Okay.
if you go back and look at, here was that Docker Compose file. That's just one piece of it, is the Ollama side, which is really what your LLM Studio and your anything LLM is doing. On top of that, we also have Chroma and the runner file behind it, that kind of stuff. So again, that's the reason I like Docker, is it packages it all up to make it look like one, where if you're going to show them in these other tools, you got to walk them through all the pieces to do that.
So like I would need a local install of ChromaDB, for example, rather than just using. Yeah. Okay, I got it. Yep. Thank you.
Mm-hmm. Yeah, so in this case, if you look at this, it's actually fired off 3 containers. You've got your Ollama one, your Chroma one, and then just the runner to build those 2 out. So really just 2 of them are kind of going through there. All right, let me see here. So we've got our Docker image up. If we follow along with our instructions here, apologize to go off on a side tangent there. Go back up here to the start. So we did our Docker Compose. There is a README file in there if you need instructions on how to do those steps. So if we do a cat README, it will tell us how you go through and about that particular lab. Pull this out here, give you some instructions, how to spin it up, and then how we're actually going to execute those out. So it's going to tell us all the pieces and the parts and kind of give us a visual of what those pieces look like. That all looks good. To kind of get you an idea of where this wants us to go, let me get if I can get a good side-by-side here. There we go. I'll pop the tab here. So if we were to follow along with the directions here of what it wants us to do, kind of scroll back up in the steps here. We have already launched our composes and all those different setups. If you look at this in Docker Desktop, you will see the one name that comes up here, which is our Foundations one, but you'll notice it spun up 2 different containers along with this runner. So that runner's ready to roll. We can hit that one and start it. looks like it was having a bug there, so no big deal. And then with these already built and run up, all we have to do is go down to here, which gets us to the RAG pipeline. And so we just copy and paste this command, run that from the same section. And what that's going to do is use our runner in order to use the Python app, which is a little pipeline in there, and kind of explain that it's going to ingest some of those files in there. Sometimes you get through there. So you can see here, we'll need to run this pre-stage, which I think I skipped that step by accident, so I apologize for that. Let's see here. Question came in. Where do I run that Docker setup? So what you do is you download this file up here at the top, this zip file, and then you unzip that. I kind of show you what that looks like in here. So I downloaded that zip file. You can unzip that, whether you do it through the command line or through the GUI here. And then once you're inside that folder, that is where you would run that Docker Compose. So if you look at the line I had up here, that's essentially what we did when we started up this entire setup. And you can see if it runs correctly, you should get this, where it's downloading those images and that copy, and then should came up and said healthy and start. Does that help you, Paul? And if that works inside your Docker desktop, you can see that those launched underneath here. So I apologize at the very beginning there. There shouldn't be a YAML file. There should be, you'll need to actually go into a command prompt in order to run that. So if you're on Windows or Linux, you just need to open a command prompt in this folder. So for example, here I could open in terminal, and then here is where I would type in that Docker Compose up. So Docker Compose up -D, which says run it in the background, and then hit enter. And you're going to see that I already have them up and running. If you didn't run this or you ran this on the first time, you're going to see output that looks a little bit like this. Anybody else having troubles? It's okay if you are, because this is why I allocate so much time to this in day one, especially if you haven't used Docker and that kind of setup before. Once you get used to it, it's very, very easy to use. I wish I could have it set for a double click, but it doesn't quite work like that in desktop. So again, the first thing you'll do is you'll do that unzip that we just talked about. You'll go into that folder and you need to run the bash pre-stage command. And what that ends up doing is downloading the models that we need, which is the Ollama 2.5. So you can see that I did that over here in this side. And you should see something like this on the screen. What it's doing is downloading the two large language models. In this case, we have a small one, which is our Nomic embed text. That's what we're going to use for RAG. And then you also have Quinn 2.5, and we're actually going to use the 1.5 billion parameter version of that. Yeah, exactly. Everything here will be recorded. So if you want to go back and rewatch and have time, you can do all that as much as you want. It's the other reason I like using Docker is you don't have to have access to external services. You can do it all offline on your computer, and that works really well. Let's see, Zhang, that does sound like a permissions issue. Make sure when you install Docker Desktop that you have the permission set up correctly. Are you using Windows or Linux or Mac? Mac, there was a good note for the Mac up here at the very top. Give me a second here. Under Setup, I need to find that command here. Apologize. Here, you just want to make sure that you have yourself set up in the right permissions group or the Docker group so that you can execute that. Yes, you can all do this in a Kali lightweight VirtualBox. That would work great too because it already has Docker installed on it. Yep. And on Windows, you just need to make sure you're running that, Paul, from a WSL terminal instead of PowerShell. And if you do struggle with it on your laptop here and you want to try it a little bit later tonight, I can get you access to one of the cloud VMs so you're not feeling like you're falling behind or anything. I can get you access to one of those during the class here today. It's not a problem. So hopefully it pulled down those two models is the first thing. It'll kind of walk you through here on the pre-staging. So the idea behind that is now we have pulled up our two databases and we pulled those out. Let's see here. PowerShell tends to not have the right execution, and when you're running Docker containers, it wants to do it under the WSL instance. You can sometimes call it from the PowerShell, but the WSL is where your actual Docker is running on the Windows side of things. It can't run it natively in the Windows side. It runs it on Linux under the hood inside of Windows. Okay. So you can see next steps here is we would just run the lab to go offline. So you just copy and paste these two commands. And what that does is kind of run up the pipeline. So I'm just going to copy those. And this is all in the README here too, if you get lost. You can hit enter. And what that's going to do is turn on the services. It's going to double check our models, make sure they're actually downloaded and installed. And then we have a collection of files inside of our folder. So if we look at those files, just so we know what we're seeing. We look at data, we have these tech files inside of here, and this will give you the idea of what it's trying to ingest into that system. So again, some of these will let you use like PDF documents. You can load all sorts of extra stuff inside of there. In this case, it's just pretty basic text files so that we can pull out of that. So in this case, it did a little query here. What's the context window in a large language model and why does it matter for security? We could say that a context window, I'll kind of pull through there. And it's going to spit that back to you as to a response as to what that is, right? And we see the wall time. And if we come down here and hit enter, or A, rather. And it's taking about 52 seconds to pull this out. So what it's doing is going out, grabbing the context out of that large language model, and then spitting it back towards us. It's a little slow on my machine because I got too many of these extra ones fired up in the background. So I'm going to slow it down here a little bit. But you can see our generation on these tokens was about 6.3 tokens per second. And it's pulling that from our ragconcepts.txt file. Notice that it has a similarity there of 0.71, 7, and 3. If we look at those prompts, we can see that we have stored in here what those different windows are, and it's chunked all of this data into those little pieces, stored it in the vector database, and then we're retrieving that information from that. And so it's pulling it out of this RAG concepts file. You can see when we asked it a question here about hallucinations. In this case, how does retrieval augmentation generation help reduce hallucinations? And it's going to, again, consume 133 tokens, generating about 6.3 tokens per second, and pulling that out of that same document and where it sourced it from. Spits us back an answer and tells us what that looks like. And then lastly there, you can see on this Lex query, what's the difference between prompt injection and jailbreaking. And here it had to pull from two separate files. So it found it in our LLM security file. If we look in here, we can see all the different OWASP top 10 security injections. It pulled information from there, and then it also referenced it over here to prompt engineering. And it found answers out of this. And so it tied those two together, giving a similarity score between them, and then went ahead and gave you an answer back as to what prompt injection really is. So again, the idea here is it's already kind of a preset demo that's going through there. If you were to follow some of those extra ones on day one down here, at the bottom we have our labs. And that first one is just meant to show you what the pipeline looks like. So it's not having you configure anything or anything like that. It's just showing you what it would look like if you had a pipeline set up. Now what we're going to do in the next lab is really look at tokenization of all those embeddings, how we took those text files, broke them up into tokens, took those tokens and embedded them into the vector database side. So I would download the tokenization embeddings. Again, I can go in here to that folder I just downloaded them from and extract that if I wanted to. Just like that. And then from here, I would come in and open in a terminal, just open a terminal prompt in that same area. And we'd run those same commands that we had before. So if I'm in here, we do an ls, you can see I also have that Docker Compose file. We could go ahead and start that one up as well. So Docker Compose up -d. And it's going to pull those files again. Now, locally, they're all going to be cached for the most part because you already did that for the first set of labs. So it doesn't have to retrieve the new Docker files every single time, only the stuff that would be missing. Unless it's changed going through there. And then again, you can always cat the README that would walk you through the lab itself. See what that looks like. And the idea here is it's going to do all of your tokenization and talk about how this works. So we're going to understand the concepts of read and write tokens and not actual characters. And we're going to estimate the token cost for like different token types. So approximately 4 characters equals 1 token in English prose. If you were to use other languages, that could be extremely larger, even if it's smaller characters. I've seen Chinese as a great example of that, where a few characters in Chinese actually mean a lot under the hood, and therefore it's not a one-to-one character or one-to-one token type mapping. We'll kind of go through what a context window, and it's kind of a hard fixed shared budget for both the system prompt, the user input, and any other documents that we pull from, as well as our output that we come out. We got to save that output so that if you ask a follow-up question, it needs to know what we have already talked about. So all of that continues to grow that context window. And then we're going to go through what it looks like in embeddings, which is setting up those vectors. Everything sits close together in this database, and then it computes that cosine similarity. So just like we looked at before, if there's pieces from documents that have a similarity, we're going to put those together so it's easier and faster for us to look them up. And we'll be able to demonstrate that semantic similarity does not necessarily mean that we have a keyword overlap. It's just the property that powers a RAG retrieval and defeats any kind of naive keyword filters. So we're not really going off keywords. We're trying to build this similarity off of this AI model. So we fired up that second one, and that's one thing you want to kind of keep an eye on here is as you fire multiple of these up, you're going to be using more and more resources. So you may want to shut down your first one that we did if you don't have enough system resources in order to do that. So for this purpose, I'm just going to shut that down so we don't get confused. Okay. And again, we would just follow step by step on the inside of here. So if we were to pull down those files, which we already have, we need to run that pre-stage command again. So if I come down here and I run the bash pre-stage, that will download any of the extra models that we may not have already had, or if you're putting them in the new system, you can do that. Yeah, no, I get it, Terry. So, and these systems are a little slow, right? That again, I didn't put these purposely on the internet with a really fast one because you have to understand the difference between these really small sets and the really big ones. And the GUI tools will make that a little easier when we talk about Ollama and the GUI and how that you can see that a little easier. As a matter of fact, I'll switch over here in a minute to anything LLM and kind of demo that for you. So right now we got our models set back up. And then what this lab wants us to do is we're going to run these commands, and that's going to let us learn a little bit about what we just did with the tokenizing, or how to set up the tokenizing. Copy that over here. Paste that in. And again, don't feel like you're getting lost or behind in here. I'm going to let everybody do this kind of stuff on their own as we work through it so they can see what's happening. So that first one just makes sure that our Ollama container's up, and then we want to run that tokenize explore. That's going to let us see what tokenizing looks like. We quit trying to copy and paste incorrectly here. It's my own system fault. So again, in this lab, what it's doing is taking that text in. We're going to use the Quinn 2.5, 1.5 billion parameter one to try to tokenize some samples. So we got some sample text inside this folder. Let's go look at what that is. And you can see these phrases, or in this case, it's using the token samples, sorry. And so in this thing, we've got some English prose, we've got some security jargon in here, some Python code, even a base 64 type payload, some hex strings, and see how it ends up tokenizing this. And you'll notice if we use emojis and Unicode, it's going to take more tokens to process this kind of information. So it's going through and tokenizing those samples now. And if you notice on a local computer and such, the CPU, and I've got a fairly beefy machine, this one here is just maxing out the CPU. And you guys are probably noticing this on your machine too, that it's just really going to max it out. Same way with RAM, it's going to take what it can in order to build that out and kind of demo that. And I have lots of extra stuff running on this machine, so you shouldn't see this much hindering it. But we can see that when it did the English prose section that we just talked about, it put that into 59 tokens. So this right here became 59 tokens. The security jargon ended up being 66 as it went through there, this little chunk here. Again, the reason this is going slow, or at least on my side, is I had anything LLM up and LM Studio, and all those are competing for all my resources right now. So you try to get those closed out in the background. So that Python code, again here, this chunk, which is very small, ended up being also about 58 tokens. This base 64 payload was about 89 tokens. Now, if you're wondering what this Python script's doing under the hood, you can easily pull that up. So if you come down here and look at the app and we look at this Tokenize Explorer, that's the one that we were just running, right? You can open this up with a student and kind of look at this Python script. And all it's really doing is using the Ollama model to tokenize those key chunks of text that we told it to. And then it's loading those samples up, splitting them out on their sub tokenization, and then bringing it back from the model and kind of feeding us that information that we just did. So under the hood, what's going on right now is this simple Python script. And this is that one part of the class where you just have to read it or explain it. There should be some good detail in here as to how that's working. Yes, blank spaces are used and counted. Yep. Sometimes it is, sometimes it isn't. It depends on how it chops it up, but it gives a really nice visualization. So now that it ran those, it's going to tell you exactly how many characters it was versus tokens. And you can see in some content, like a base 64 payload, we got way less token or less characters per token than we did in something like English prose. If it's regular English, we got our best characters per token out of it. When we got down to Unicode and stuff like that, that was actually the worst one as it went through there. But we can see exactly how it chunked it out. Now, there are some other good tools in there, and this kind of comes back to that resources page. So back on our website here, if you open up this resources in a different tab, and this is kind of something I learned from the last workshop, is people need links. It's great to come learn at these workshops, but the worst thing is Monday morning, you guys come back in, you're like, how do I do this? Or what were those links again? So this page is designed just for that. Anything I talk about in the class is going to be put up on this site. The site's going to be up for long after this workshop, where you can come in here and kind of click on these and anything that we talked about. So while this obviously showed it in this quote lab environment, how to let them see what it did for tokenization, we can do that same thing with a tokenizer, and those are randomly available on the internet, very easy. So if I come up here and grab this English prose text and copy that, and on our resource pages, you have something like this TikTok tokenizer, right? All this does is allow you to paste your content in and hit add message, and we can see the token count that it came back in. So we can see how it got put in this actual one. And this is based off different models that are out there. Every model tokenizes things differently. So this is a great way for you to kind of see how that compares. This one, what's interesting about this one is it doesn't just give you the text and tokenize that. It's also showing you what it looks like when you have a system prompt and a user prompt along with that text. So we'll come back to this one because that's kind of a jump ahead. This one from Hugging Face is a great example. So if I copy and paste that, you can see if I was using GPT-4o, that ends up being only about 30 tokens inside of there. If you wanted to see the token IDs, you can kind of see how it chops those up, which looks like that. And if we were just to hide all that, or the tokens. So these are great tools to get people to visually understand that one character does not mean one token, or one word doesn't necessarily mean one token. For example, triage here got split, but even the long word increasingly did not get split when it got tokenized. So it's a little different every time you use it. If I bring this up, you can see that we dropped a token because we had that enter character or that return character in there. That does make a difference when you look through there. I'll pause here real quick. How many of you have actually played with Hugging Face or are familiar with what Hugging Face is? Okay. Not a problem. So as you're playing with these AI tools, the best ones to get started with, like we said before, is going to be Olama is a really good one. This is a great place for you to download their software. You can launch it locally and play and interact with it. The only problem with Olama is it doesn't really have a GUI front end. The newer version does, where you can actually have a prompt like a ChatGPT style interface. Another good one inside of there would be the LM Studio. We talked about that one. And we also talked about anything LLM. Those are all listed here, by the way, underneath the RAG resources. It'll take you out to go look at those. If I was to you to go play with something new, Olama is a decent start, but I would go with either LM Studio or anything LLM. Those are great ways for you to kind of show what's going on, but also have a chat interface that you can interact with. Olama runs more like a server in the back end. You still have to have a front end. The very first one I ever played with was called Open Web UI. You kind of run it as a second Docker container, and it gives you that Chat GPT style interface. But anything LLM is really good at doing everything all at once. And LM Studio is better at showing you how models are loaded into VRAM and how you can adjust context window sizes and how that affects performance. You can do it really, really fast. So all these tools are great for learning AI models, how it is relatable to tokenization and context window, and then also testing them out on different systems to see just how much resources you have and do you have enough resources. So again, this is all available under the resources tab. And then these are all different tokenizers that you can see. One thing I did wanted to do was put up Anthropic costing in the same way with Google in those. So what I wanted you to be able to see here was everything we talk about is in single tokens. And when you pay for these high-end API services, everything's measured in million tokens. So if we were to send into the system 1 million tokens, it would cost us $10. It would cost us $50 for every million tokens we got out of their system. That doesn't mean 1 million words, right? Because we have our system prompt, user prompt, all the context we're feeding it, all that stuff inside all costs tokens. And so this can add up fairly quickly. 1 million tokens is a lot of tokens, so you can interact with these systems for a while without charging a full $5. Every frontier system, whether it's Claude, OpenAI, Gemini, they all have their different pricing structures. A lot of them will have these type of structures, which is what most of you are used to. For example, ChatGPT, you pay $20 a month, you get access, right? Same way with Claude, they have their $17 package or their $100 or $200 package where you can interact with them. And what that does is keep you from having to pay for the API cost directly, and it's kind of subsidized through a everything is included kind of thing until you hit their limits, and they all have different limits inside of there. But these are great ways to get started and kind of understand what's in there. And then as you're really using the heavier resources, you can definitely go to that. Yeah, a $20 ChatGPT or a $20 Claude account is the best way for you to kind of understand how things are going. It's very rare, unless you're doing lots of deep coding, that you need to go up to their $100 or $200 plans. It's really if you're doing a lot of coding is where you start to need these. And then, yeah, you can, if you're doing it for production. So like when I do this with the software development company, I'm allowed to use those kind of plans to build out some of the content. But if they're using AI under the hood, for example, if I'm using it to analyze those farmer tickets that we were talking about, now I have to come back and actually pay for this API access. And these are, as they're listed here, for example, with Claude, I just happen to have up. These are, high-end models to the lowest end model, which is their Haiku model. I use their Haiku model a lot because I wrote enough tools under the hood that I don't have to pay for Fable to do the stuff I need under the hood. I just need this Haiku to be a director to say, oh, you're asking for such and such tool. Let me go get that information out of that tool and bring it back to you. Well, it doesn't have to be smart. It just has to know what tool to go use. And therefore, it's very cost effective. I can get that down to, analyzing tickets is less than pennies when you're using this API, and I can do that all day long. So it gets pretty cheap. Prompt caching is going to help too. So as you're interacting with it, you're going to get a little less cost if you're reusing that same prompt over and over. It costs quite a bit less once you get using it. Okay. So again, don't want to get sidetracked, but that's all around what we are trying to do on the prompt, which is understanding tokens and context window. So a good example is if we have a window of 2048 tokens, we can fit 34 copies of that English prose in there. And if we put 34 in there, we're only going to have 42 available left over. All right. If we have a 32K context window, well, then we can fit 555 copies of that in there and have leftover for about 23 to answer any questions back. And so when you stick things in your context window, that's going to be, again, a system prompt, a user question, the retrieved RAG chunks, and then the model zone output that all shares this context window. And once it fills, the system literally, for lack of a better term, goes haywire. It starts dropping things. It forgets what it was talking about. And you start to get that data back that most people were familiar with in ChatGPT about 4 years ago, where it just starts hallucinating and giving you random answers that have nothing to do with what you asked. You got it. That's it. So the beauty of that is you get these much larger context windows, and that tends to go away. So when you have Claude with 1 million token, it definitely goes, the concepts of those start to weed away. But you got to have some really good hardware in order to pull that stuff off. So even with our real basic hardware we have here, we get an idea of what this context window looks like. Now what we need to do is actually embed that in there. So we need to understand what it looks like for us to embed that into our database. So I'm going to copy this out here. And so the next command we would run in this lab is our embed explore Python file. And if we go look at that file real quick. So what this script is going to do is use Ollama again. We're going to verify the embedding model is ready to go. We already have a copy of it down. And then we're going to embed those bundled phrases that we had before using that nomic embed context window. Or I'm sorry, the model there. It's going to compute any kind of cosine similarity, which is pure Python, no NumPy or anything like that. We're going to have the most similar phrases in there and the least similar phrases based off word matching or shared words or related meaning. And then we're going to do those nearest neighbor searches to do some queries to try to pull some information back. So again, a lot of this all happens under the hood, but I'm trying to pull back the curtain and explain what's really going on under there. It's good for students to understand the concepts. I personally wouldn't dwell in this, so I'm going to teach a generative AI class this fall. They should see this and understand what's going on. But unless they're actually writing models or optimizations or that kind of stuff under this way, you use the first couple labs like this to explain it. Same way in the cert, you got to be able to explain it to understand what's going on, but it's really not something that you would do on a day-to-day basis like I do, or anybody else using AI and software side. All right, so let's run that script. And so if we look at the output of that script, it's very, very fast if you didn't notice. So this model took those individual phrases. Again, those phrases we told it to look at were, hold them back up here so you can see them. Phrases like this. So something like account access, reset my password, credential recovery for a locked account. I forgot my login. How do I do that? All these little phrases they're trying to map out and put in our vector database. This would be the equivalent of us feeding it like a bunch of Word documents or PDF documents, whatever the system can accept, so that we can store that information. So if we look at those different phrases, we can see phrase A, I forgot my login and can't get into my account. Phrase B is help me regain access to my user profile. It matched that with a 0.681 similarity score. Right. Note that there's no shared words there. It wasn't until we got to this shared words one down here, the Wi-Fi in the conference room keeps dropping, the password to the Wi-Fi is posted in the break room. Well, those aren't really two similar things other than they use the word Wi-Fi over, right? But the idea here and room, so they don't have a very good similarity score as it goes through. Now, if we look at other phrases like my laptop is infected with malicious software and click the link below to launch a lunch menu, obviously those are dissimilar, and so they have a much lower similarity score. So if I was to run a query of something like I am locked out of my account, then it would try to go find these nearest neighbor searches and what that vector store would give you back out of our database. Again, what you would load up with your vectorization would be like manuals that have been written by a third-party company or yourself, or documentation, that kind of stuff. And it allows you to do a quick search. This is much better than a keyword search that you guys are used to, like Control F. It's going to pull all that context around there to feed you an answer of what it should be. So when we're doing vectorization, cosine similarity on 3D graphics, the numeric vectors are being compared numerically. Yes, that's exactly what's happening. Yep. And again, if you want to pull back the hood on that, you can look at the embedding one and we can see the math or how it's going about that and doing this cosine similarity between them.
Jason, are you aware of any already embedded data sets that have, say, all the Windows of event log codes and descriptions, or the Linux event log codes and descriptions?
Hugging Face is going to be your first place shop. So by far, anytime you want data sets, Hugging Face is like the candy store of anything AI. And so you're going to find data sets out here that you can download, like pulling full Wikipedia or sets of stories or anything you're wanting to play with on this RAG side. These data sets are good for that.
Cool.
The Spaces is kind of a place that you can execute some of this against, buckets, and then models. If you want to take somebody else is working on a new model and you want to check out their model, this is a great place for that as well.
Thank you.
Uh-huh. Does this answer your question under the hood, Marla, when you were asking about the math sign and how it actually breaks it out?
Yeah, I was just looking at it because I'm trying to do the AWS AI and of course the practitioner one, and they're just like going crazy with training models. So I was just trying to see how this works in relationship to I know I've seen the graphs where they have like the XYZ coordinates and then they have like pictures of dogs and puppies versus cats and kittens and where the vectors lie. So that truly is just a mathematical relationship between the two, right? When
You
they're
got it.
training the models.
Yes.
Okay, and so the closer to 1.0, that would be the closer, well, 1.0 would be exactly the same, and
Right.
anything going down to 0 would be less similar.
Correct. Yep. And that's
Okay.
purely when it's doing that cosine similarity. It's just one way of doing vectoring database, but it's the most common in what they're using.
Okay. Okay. Thank you.
No problem. And again, the model that we happen to be using is this Nomic Embed vText. There's a lot of other ones out there. So if you look at, I believe I put it out here in the references or the resources. Okay, they just pulled up underneath here. So I'll show you how that looks, for example, in anything LLM here. And I'm going to pause before we go to this other lab here, which is the RAG retrieval failure, where you can see this in the GUI side. So if we were to use this and build over a document set, this is going to give you a rough idea of how to do that same lab over anything LLM. So when I first fire up anything LLM, It wants to know what model I want to use, that kind of stuff. If we were to set that up very similar to the Docker stuff we just did, you could come in here and pick a model. Now I'm going to grab this 257B. It's obviously bigger than the 1B that we're using in the Docker side, but the concept will work the same. So I would click that one and you hit save changes, it downloads it. If you come out here to the vector database, you could see that they're using a different one, which is LanceDB. In the lab, we are using Chroma, or PG Vector is also another popular one, which uses Postgre. We'll just leave it at the LanceDB. This is just what the database is running. If you look at the embedder, this is where you have anything LLM's version of its embedder. But if you scroll down to all these other people, you can see all the different ones that are out there for embedding different pieces. And if we look at the model, you can also see that Nomic embed text is pretty popular. So anything LLM has a couple other models that you could use, like this mini one. It's only 23 meg, and that would allow you to get better and faster embedding text. Other people have better models for doing that same thing too. It depends on what you're ultimately doing. If you have a third-party subscription like OpenAI or Gemini or Claude in those, you can connect those here in anything LLM. So it's kind of handy to be able to use those third-party ones. I'm just going to stick with this one here. And again, if we look at the Nomic one, that one's 139 meg to get down that model that we were using. The one that Mini LLM recommends is only down to 23 meg. What's nice, they will show you the card on Hugging Face. Like I said, Hugging Face is kind of the go-to depot for anything AI and getting models or data sets or anything like that you're trying to see what's out there. This is a great place to go play. Now, all of these are using transformers under the hood in order to pull that in. And we talked about transformers earlier. This is how you get that data over there. This gets really heavy in the machine learning side of things, more comp sci version than what we're trying to use on the cybersecurity side. But if you want to get that nitty gritty, this is kind of the place to get that information from.
Jason, I have another question. It's Marla.
Yeah.
In terms of, I was listening to a podcast yesterday, and they were talking about the difference between open weight and open source models for
Yes.
LLMs. Can you kind of go over a little of that, if possible, what the difference is?
So most of the open source ones means that they have turned over all of the model and the weights or the data sets that they've also used.
Mhm.
Open weight ones, they typically are retaining the rights to the model, but they used open source data sets or open weights in order to train their model.
So it's just the model training is what they're allowing you to see as far
Got
as the using it. Okay.
Yeah, so it's really whether the licensing of anything you generate with theirs is yours or is it truly open source. And that's where you can come into like these data sets, right? So there's lots of controversy on that side. For example, you will see complete Fable 5 traces, whatever this one is. Well, the problem
Mhm.
is these guys generated these data sets with Fable, but that doesn't make them open source data sets because Fable is actually a closed source private model, right? So if you're training your own model with things that were generated off this, you get into a licensing issue because it clearly states in some of these that you don't own this data. That was our data, even though you used our AI to generate that data. And you'll see, like right now, there's a big thing going on with book publishers and other people that had these massive data information sets that got scraped off the internet and fed into models, and then they became open source models. Well, all their stuff is out there, right? Or these programmers that were dumping in lines of code into ChatGPT to have it troubleshoot, but they were dumping in their firewall configs, or they were dumping in a bunch of other stuff to have it checked against. That, ChatGPT was very straightforward in the early days. We're using this information to retrain our models. Now your entire firewall config is out there for that purpose, kind of thing. So there's a fine line when you're walking between your open weight and open models, which is what I was explaining in the beginning. most people don't build new models anymore because of the cost it takes to do that. They build the data sets and then they take a very good basic open source model and use either RAG, or they then retrain that basic source or that basic model specifically for what they want it to be focused on.
When they're talking about small language models like the ones that are being used for medicine or for law or finance,
Uh-huh.
how does that interact in terms of being able to use like create agents or create, code using just those models as opposed to using, ChatGPT or the larger models?
Yeah,
Are those
so
always running local?
yeah, most of that would have to be on the local side when you're pulling that in. So when you have something
Okay.
like, for example, Opus, Opus is what they call like a mixture of agents, or it had some of these newer models have that very specifically. A good way of these multi-model models. What that does is allow them to have the ability to comprehend text, images, vision, that kind of stuff. Some models have that ability, like these Quinn sets that you see in here, where you can put in text or an image. Some of them are text only. So the Quinn 2.5 that we're using in this right now is text only, is all it can read. Kimi and some of these other big ones, they have more of that agentic capability, which means you can go out and do instant mode, thinking modes. That was kind of a big thing here about 4 months ago. Is you started to get the thinking models, and that's where DeepSeek and some of those other words, instead of just retrieving whatever it thought came back, it would run that through a filter and make sure that was the answer it wanted to give. So it took a little more time for that, but you got a much sharper answer out of it. Now you have ones like these mixture of experts ones, and what those do is have a little bit of everything that goes through there, but they're only activating certain ones at certain times. And what's nice about those is they don't have the hardware overhead. It only does it at runtime and mixes that context window with the information it needs. Did that sidestep, or did that actually help at all?
Well, I haven't got to the coding level yet, doing the vibe coding and all that stuff because I'm not a coder, so I'm just putting that out there.
No, yeah,
But what I'm trying to do is as I've been using these models and everything, is to get to that agent, the agentic AI part
yes,
and be able to run applications or do applications that are related to like medicine. So, for instance, I started with ChatGPT a long time ago, and I started looking at maternal mortality in diverse populations. So I did a deep dive looking at the numbers and what it had available, and I've done it a bunch of times. But I wanted to be able to apply a model that was more trained on medicine as opposed to like more of a general AI
yes,
training so that I could come up with more of a kind of a research base, either application or a agent or something to be able to track and figure out why there's such a high maternal mortality in certain populations. And
gotcha.
then apply that to an actual application, either some type of app or mobile app that could, interface with the doctors, interface with the hospital, interface, just kind of more generically with the patients, through wearables and things like that as well. So that's what I was kind of looking at. And when they were talking about just the cost of using, the general agents like, Claude and everything, it was saying like some of these things you could probably do with just more local models that had
Absolutely.
just embodied medicine. That was all that it had, So I was just wondering how that worked, without using like the bigger models or foundation models.
Yep. And so really what you're wanting is you don't need that basic model that has a lot of foundation. If you look at these through Olama, you're going to find that. So if we
Hmm.
find something in here that's more, um, yeah, this was one that I'd used in the back. There's MedGemma and there's a couple other ones. These
Okay.
are more focused on reading medical text and image comprehension. So they're smaller. If you get into like
Right.
4B ones or even they had some really nice 0.5 models. But what it was meant for was it understood medical jargon, medical text. It didn't need to know
Gotcha.
everything else out there. So if you use those small
Gotcha.
ones, it runs way more efficiently on the edge. And then on top, like this would be a really good one for vision side of things.
Mhm.
Then what you do is you build your database of everything you're wanting it to do, and you build the tool under the hood, which is called an MCP server, and we're going to get into that by the end of the week. But that would
Right.
start doing lookups against your data sets and the data that you're storing in your own database and looking up
Mhm.
there first. It knows how to read it, so therefore it's a much faster system overall.
Gotcha.
And the
And
cost
because
is
it's an edge, go ahead.
sorry, the cost becomes really negligible because you can run it locally.
Gotcha. And so, like, also because you're running against edge devices, you can do like real-time monitoring if you have like a wearable or you develop, a wearable.
To some state, yeah. If you keep it small enough on the edge device, you could do that. That's why a lot of your smart rings, smart watches, those kind of things, those are just feeding data back to the phones, and the phones are now capable of running like this Fi. This is one that we ran on cell phones, for example, Fi 3. Um,
Okay.
it will then take that data in and be able to do that almost in real time because that model's so small and focused on what you want it to actually be doing
Okay.
instead of trying to
Okay.
be a master of everything.
Yeah, and that's what I'm looking at because, with this one particular problem that I'm kind of researching, it has to do with a lot of the blood pressure measurements, that can be taken in terms of a wearable or some type, even oxygenation that can be taken as a wearable, and that data set be kind of fed in. And when there's a tipping point or when the information combined says that this is a risk, then that person would be alerted or the doctor would be alerted to like, now you need to go.
Yeah, exactly.
Before you
So,
get from preeclampsia to eclampsia, like you go, go to the hospital.
yep. And unfortunately, I'm all too familiar with all this stuff. So my wife's an ND, and she's actually just running all my blood work and everything else this last week. And me being this AI techie side of things, I'm all right. Well, feed me all my labs. And I think she ordered 52 labs on me last week. So I gave more
Oh,
vials of blood than I've ever gave. Um, but the idea was just that it was let's do your labs. We're going to make some tweaks in the things you're doing. Normally, you make a little tweak, you wait 6 weeks, try to see what changes.
right.
In this case, we can run those faster, and they have a lab service that pretty much I can run labs every week if I wanted to. But I can feed that all into a database, exactly what you're talking about, and see those changes
Mm-hmm.
over time. And then as her clinic is running those kind of services, we can feed all that information in to make better ideas of how those
Clinical
changes are making
decisions.
that thing over time.
Gotcha. And so you're not just going at the tipping points of the labs being abnormal, but actually looking at the increase, as being a marker of disease as opposed to just like, every 6 months getting labs and that type of thing.
Exactly.
Okay.
Or
Okay.
in her case, being on the indie side of things, what supplements actually make those a change versus full
Mhm.
prescriptions kind of thing. So does this one obviously? I mean, she's got the background history of the what supplements do what, but as you know, when you
Hmm.
prescribe those kind of things, they affect everybody differently. And so if somebody has
Correct.
these markers and they do this change, how does that affect these overall numbers in different places? Or like, for example, cholesterol will look bad right now for me. I don't care, right? So she's looking through that and going, well, we kind of know why that is because you were doing this X, Y, and Z, and we knew those numbers were going to come back a little lower than they should. But at the same time, these other numbers balance that out. So those are all great things for an AI to kind of help comprehend going through there. The doctor ultimately makes the call, but it can help her
Of
feed the
course.
information. And medical is one of those that uses those all the time. And in her case, most of what it is in the note processing or SOAP notes when you're writing your clinical notes.
Hmm.
Um,
Hmm.
the clinic is very good about utilizing that to make sure that they documented all the extra stuff that's on there and then the things they don't think about. And she builds up a template of what she wants it to be, and then it answers based in how she had the template, and she can go verify that, you know what, I always like to tell them about this when I talk about this topic. Did I mention that? Did I put that in the system kind of thing? So,
Man, when I was doing clinical medicine, this would have been great to have.
You got it. And
I did this.
in the
I
early
did
days
this
of my
all by
PhD, it was
myself.
great.
Did this all by myself.
Yes. Yes, yes, yes. So yeah, that is that one. I think there was
Gotcha.
one last step I had in this lab. Make sure I pull
Okay.
that up here. Yeah, so in this lab, that was what you had were those two there. You can go in and edit those phrases and queries and kind of see what the difference is. And the anything LLM, what I was showing you here is you guys can use the different embedders and kind of do this in a GUI format. It's a little easier to play with. And then when you come back, you can actually run those queries here. So I can say something like, hello, we'll make sure our model fires up here. It's going off and doing that. So it's got to load that back into memory. Once it comes up, it's significantly faster when it does that kind of thing. Together, man. There we go. So we can see that. We can see that it took, it's really slow on the generation, and that's probably because I got so many things running here. But the second time I do it, and you can see it's generating much faster. So once that model is loaded up into memory, which we can even see here on this side, it's loaded up into memory, and the CPU is doing all the crunching to try to talk and process this side. But it's much more fluid. And now we're up to that 8.5 tokens, which seems like a natural talking conversation, generally above 10. You'll get to the really fast models that'll really start spitting it out on the screen, but they're not in depth as to the responses there. If I wanted this to particularly talk about a book or something, then I can come in here and do the RAG portion, which is where I got my workspace already. Let's just create a new one. And then inside this workspace, I can upload a document. And let's just grab one that we were talking about here, phrases. So go to the workspace, save and embed. And so in the background, it literally just went through those phrases, embedded them into the section there. And then now if I was to ask a question in there, just need to tell them which one. Now that they switched to this agent-based side, that's kind of what it's doing is firing up a second chat thread, going to communicate with that. That's what an agent is. And then pulls all that information back out of that phrases.txt and loads that all up into our context window so that we can see the different phrases that got extracted out of that particular text file. So whether that was a PDF or a text file or maybe a log file, if we're on the networking side and you want to play with this on your SOC, NOC type setup, this is a great way for you to go back and correlate that information there. So if you load this up with, say, 4 or 5 files in the quote knowledge base, it can go through and try to draw some similarities of things that may have been happening in those logs. So generation is still pretty reasonable for this little setup. Now, again, this laptop has a pretty good, a really good system RAM and CPU, but it is not high firing on the GPU side. So if you were to give this a GPU-based laptop under the hood, it would really crank up these tokens per second. And if we look at our sources, we can see it's specifically pulled from that one that we were referencing there. So that, again, this is a kind of a visual representation of what's going on here. Only this is giving you that nitty gritty, explaining those similarity scores and how those things are popping out inside of there. And then the last one we have here, and this will be before we go to our next break. Back to the labs. Would be this RAG failure. And the idea here is that it's pulling from the wrong side of things. So we'll go ahead and download this zip file. Now, if you may have noticed when it's doing this, it's also rebuilding those container files every single time. It will cache the initial ones that you download and pull them in. The only negative to this side of doing it is it does have to re-download the models every single time. So you can make this where it's an all-in-one Docker container, and then you just tell it how to start. And that's generally how I do these. This one I purposely left this way for today so that you can see the pieces. But if we fired up just a single Docker container, then you could have multiple labs within the same container. It's just a different way of doing it. It saves a little bit on bandwidth, but if somebody messes something up on that container, you can't guarantee lab 2 wasn't affected by lab 1. And in this fashion, it's always consistent and always works. So under the hood of something like NetLab, this is how we tend to develop those, is so that every lab you do is always consistent. Lab 1 doesn't affect lab 2. So they focus on the content of lab 2 and not whether or not they did lab 1 correctly. Especially if they're needing to do lab 1 over and over and over again to get those concepts. So this one was able to pull, and if we do an ls in that folder, we also know we have our readme again. So let's cat that readme. And we're probably going to need to do our bash script, which we do, bash pull. So let's do an ls bash pre-stage. And that's going to grab those models that we need. Thankfully, they're pretty small. Yeah, you do have to run that bash command because, again, it's treating each one of those as a separate Docker container going through there. And that's the reason you want to make sure you go back and stop your old one, which you could do a Docker down and it would just stop it there. I'm going to go ahead and stop that token embedding one. Now, if you remember, Terry, like when I did the workshop in Christmas, basically, or whenever that was, the holiday one, I basically had loaded up all the different Docker containers and made them live, and then you guys just accessed them directly, so you weren't having to spin them up every single time, or it spun them up on the fly. Yep. Those are pretty easy to do with the ones that we were doing in those instances. When you start dealing with the AI models and stuff, you kind of have to break it out a little bit in order to pull some of that up. So that pre-staging was done. Now what we need to do is just make sure Ollama and Chroma are up, which I believe they are, but we'll go ahead and double check. And it looks like those two containers are running. And then in this case, we have a RAG eval script. We're going to go look at that before we actually execute it here. And again, if I would stop hitting the wrong key on this system. There we go. So before I run that, let's go take a look at what that Python script is doing. Whoops. And so this one is going to build out a RAG pipeline like we had before. It's going to run that Nambic text, Chroma, and Quinn all over the thing. And the idea is we're going to retrieve some information and some similarity, but we're going to end up poisoning the kind of data that comes in there. Notice we're going to give it a nice little system prompt, and we'll talk about that system prompt here in a minute. So we'll run that. It's going to double check, make sure the models are good. And of course, now I've got other stuff chewing up the background here. So So if we go look at that data that it's processing there, we can see these incident response type files that it's talking about. This is all kind of building up its knowledge base. And if we look at this reference file, we can also see that we're adjusting a little bit of the system prompt with some of the stuff coming in here. It's going to show us that here in just a second. So we asked it a question that would be like, what is a 3-2-1 backup rule and why do we keep an offsite copy immutable? It pulls from our setup and says that that is at least 3 copies exactly. And it's grounded in a 1.0, meaning we had some good answers as to what was coming out of that. We can also see that on this one here. So which second factors are approved for MFA? We can see where those are coming out here with a very strong answer as it comes through here. But at some of these, we're going to end up poisoning as they come through here. So, and that would be this one here. So now that it gave us those feedback and those answers and we poisoned it, we can see that we retrieved it. And that was that system note, which ended up injecting into our system prompt. And so you guys can go in and edit these, you know, your eval queries and the poison that's in there. And we can see those coming back. And the question was, how can I improve VPN performance when that particular one ended up coming back? It's poison. And we can see the split tunneling of measures. So very short lab. It's not the best of demos, but the idea is that it's showing you that if you ingest bad data into your vector database, you can expect bad data coming back out of there. And so as you're building out your RAG pipeline, whether it's anything LLM or you're building out your own, it's a great way to comprehend the data. You just got to make sure the data you're coming in with is clean and sanitized. So if you're pulling stuff off Hugging Face without checking the data coming in there, you know, you're relying on somebody else's data to build that out. And if everybody shares bad data, then those will be bad data moving forward. Hugging Face is usually pretty good about that because they do some checks in there. So. All right. So those were 3 very basic labs, and I get that they were basic. We're going to get into much more detailed, much more interactive stuff as we go through. But in those early stages of just understanding tokens and how tokens get chopped up and how you're going to do some RAG and embedding, these are some great tools for you to kind of follow up with and be able to use it or demo in the classroom too. LM Studio, since I talked about it a couple times, let me bring that one up. So with LM Studio, you can pick your individual models just like I did with everything else. I could go download some different ones. I'm going to try to grab the smallest one I can here. I think this 9B is the one I have. So here. There we go. And within LM Studio, you can come in here and adjust your context link. So it'll tell you what the model supports. In this case, it supports up to 262,000 tokens for that. But you'll notice right now, I only have 4,096 is all I have in tokens available. And I'm fully offloaded to the GPU and the CPU. So you can see I'm maxed out here as to what it has. As you adjust this slider, you can see how much more memory or less memory it's going to take. But if I wanted to max out this context window, I would have to have a full 16.8 gig on the GPU, and the rest would end up getting offloaded out of there. So having a great context window is good because you can last a little bit longer, work with the system, load up the prompts, all the stuff. But it's going to chew up a whole lot more video RAM in there. And it's really this unified KV cache that really shows how you're going to be saving your memory and how long you can work with things. So LM Studio is one of those. If you want to play with the really finite numbers and understand how that stuff truly works and how you tweak one little section and it makes a big change, LM Studio is the best one for you to tinker and play with that side. So you could start with a really small model, and then if it has a really big context window, you can crank it up if you have enough memory usage and really play with it. If you get those that are more tool-based, like some of these ones that you're seeing I have up here, That is ones that you could use as a replacement for things like Claude Code, but they're going to run very, very slow on systems that don't have a lot of memory in there. So if I'm loading up this ADB context one, locally on my machine, I'm going to need a whole lot of system RAM and a whole lot of GPU in order to offload that. And you can see as I crank that up how much more that requires. Let's see, anything else in here? This is just that vector data store. I showed you in anything LLM, there was the PG vector, and I'm used to that one because I'm more of a Postgre guy on the database side anyway. So it made sense. I at least understood the context of how it was storing it. But all of these seem to work really, really well. Nothing I would fight over more than one or the other. Ollama is very simple to get started. Again, you got to have some kind of front end UI. That's where OpenUI came in. Anything LLM kind of put that into one package, and LM Studio lets you still work with Ollama, but it lets you deal with those little parameter changes and vector changes so that you could go in there. For those of you looking to host your own models, Ollama is pretty much the golden standard there. There are other ones that would allow you to host those a little easier. LM Studio, you can do that directly, make it available to other systems on your network. VLLM, which I don't think I put that in here, but I could show you that one. This one is allowing you to do a very high throughput. So if you want your best tokens per second, you would use VLLM to host those files out. When we did the hackathon, that's kind of what we're running under the hood is VLLM, but it's very picky on its parameters. And so there's a lot of setup and tweaking and things like that you got to do in order to eke that last little bit of performance out of it. Very hard to work with, but when you do get it set up, it's extremely fast if you're going to use that method. All right, so again, at the bottom of day one down here, there are those alternatives, and this is going to walk you through what it would look like on anything LLM. So you could walk through these steps. These would be good alternatives for students. Going and playing with broken tokenizers and such. I kind of just gave you skeleton labs that were out here that would get you to explain how that would work. LM Studio is a good one where you can learn about temperature and how temperature affects what a model feels like, whether it's slow or dumb or, all those kind of things. Temperature is a great one to adjust, which is also along with your context window. And then, patching those two together, paste something like that. So if you're looking for more explanation of things that we went through today, these are great labs. That's kind of what I planned on here after the 3 o'clock was letting everybody kind of play with those different tools. And that way, if you had questions before we jump into tomorrow, we can go in that. The big question I have for everybody now is what kind of tools do you want to come out of this workshop so that you can utilize this in the classroom? So I would say, for example, the Docker containers work, but do you truly find those useful in the classroom, or would something more tailored to LM Studio with labs written against that, is that better, or anything LLM? Being able to build the labs?
Yeah, I generally find LLM Studio to be the best to work with, just because with Docker, there's all kinds of dependencies and stuff, and sometimes they don't have root.
Yes, understood. Okay. All right, so I can help build out some more labs against LM Studio, the ones that we have showcased in the next few days. And then Marla, when you're asking about building out the labs, essentially, how did I build this under the hood? Is that what you're looking for?
Yeah, just something in terms of like some type of template, or if I'm trying to build I'm actually doing a lot more networking than cyber right now, but I do both. But I just wanted to be able to build some of the labs like this to include AI into some of those networking classes. And I've done, like some agents or like tutors and stuff like that, but I like to actually do something where the students can get more out of it.
Okay. Anybody else have ideas of what they were looking to get out of this week? Like I said, the first day I kind of slow play it, see what the group wants. Sometimes they know exactly what they wanted out of the week, and then other ones are like, you teach us what we're going to do this week. So
Probably the only other thing I can think of that would be helpful is if we contextualize some of the work for common cyber work, like work tasks. So you think of things that would require basic reasoning or synthesis skills, and then working at those. So something like a junior analyst or somebody who's just entering the field would have to do. So basic use cases. Now, because the thing we have with students is they don't really have good hardware, so they can't really run any expensive models, but they want to know what it's like on the job using this stuff.
okay. So you're looking basically down to that SOC analyst type stuff and how that would be applied there.
Yeah, where there's overlap with IT. So think of things like host admin or host evaluation, um, how to do log file analysis or interpretation, things that are like very basic use cases that don't require a lot of setup.
Okay. And how is the hardware in your guys' classrooms? You have access to at least servers, lightweight computers? What kind of hardware do you guys have access to?
The standard systems are generally pretty basic as far as VRAM goes. I think our recommendation right now is for 8 gigs of VRAM at the most, and a lot of times students don't even have that.
Yeah, I mean that'd be a pretty beefy
Yeah.
laptop at these days.
Yeah.
Another good question is how many of your schools have access to some kind of frontier model for students? So whether you guys are Gemini from Google Workspace or um, Copilot with Microsoft, or maybe you are an Anthropic university, that kind of thing.
We have Copilot, and on the back end, you can toggle between ChatGPT and Opus.
Okay. A lot more Copilot. Yeah, I know that seems to be popular. I think that's the one they actually have here at Fort Hays. Um, we're working on getting, hopefully, when Claude launches their education one again this fall. It's a great way to do like these little mini hackathons. You can get discounted accounts and stuff that are specifically meant for that kind of thing. Even these $20 accounts. As far as students, have you seen them really after the $20 accounts, whether it's ChatGPT or Claude or any of those?
I think it's kind of all over the place. I mean, we have a fairly large student population, so there are definitely ones that have it. How effectively they're using it or what the use cases are, we don't really have any insight into.
Gotcha. And Carl, you're saying they're just using the free resources? Okay. Is anybody teaching classes where they're requiring some of these? Okay. Would there be pushback on that kind of thing, or what's that look like at your different institutions? In other words, would it be treated like a book kind of thing where you're saying we need you to have that subscription for 6 months or whatever the class time is? $120, it's about the equivalent of a standard book, that kind of thing.
Right now, they're allowed to use Copilot with the enterprise version, but it's actually a basic Copilot, so it's not even the advanced version for all staff and students because we are, for Microsoft. And what I've been told is that the state of Georgia is actually looking to do some kind of contract with OpenAI. So we may have access to ChatGPT, like a more advanced version of ChatGPT Enterprise, within the next few months.
Perfect. Yeah, and that was even the problem like with this course when they asked me to do that. I was like, oh, that's great. Are you guys able to give them any kind of frontier stuff? They're like, no, we got to keep it at the basics. I'm like, well, we can do that, but 5, 6 tokens a second is what everybody's going to be seeing when they're coming through here. And it's good. I mean, like I said, when you learn the basics, that's great. But when you really go to want to try to use it in the classroom, you either have to have some resources behind it or subscribe to some of these frontier models and be okay with the data going out there. And most of the circles that I talk about with industry and that kind of stuff, the good employers, so to speak, are really embracing it. Obviously, you can spend a lot of money on A real fast if you're not sure what you're doing, right? And so a great example of that was last fall when I was getting hot and heavy into this and I was contracting with another company. It almost seemed like a Chicken Little type thing. By about January, I was like, guys, we have got to switch now. Like, you don't understand. We're going to be way, way behind. And they slow played it for about a month and a half to like get the director to really kind of understand and use it himself. And it switched extremely quickly after that. Within about 2 weeks, everybody understood why I was raising such a big deal on changing everything. And we were able to get a year's worth of backlog software rewritten, tested, verified, used through beta testers, and handed out. And it completely changed the workflow of everybody in the company. So it's whether or not you think you're going to use it as a quote tool or if you're going to truly embrace it. That doesn't mean you do it blindly. There's definitely got to be a human in the middle still at some point, but there's a lot of times even that's starting to fade away if you get the right setups. So. See, I know you guys were looking for that SOC analyst and trying to do that. You said some of you were networking background. Have you guys demoed what AI can do in the networking side of the realm or help with configurations? Has anybody played with that, or do they teach that in the classroom?
Not at this point. For my division for networking, they want to basically invest, some type of AI or use of AI in some of the networking classes and kind of integrate that in there, but nothing specific. I just use it more for developing content and also doing engagement activities. So I've
Okay.
set up like tabletop activities and games and gamification and stuff using AI, and then also setting up kind of the background of being able to audit my classes and make sure that everything is included in what they're supposed to be, and I don't forget. So it's more of a tool to help me as opposed to the school at this point, but I do know the capability is there.
Fantastic. What kind of networking content are you using?
So I'm quote unquote the networking specialist. But we have courses, just fundamentals of networking. We also have the Cisco track and we have the Microsoft track, and AWS is our cloud computing track. And I'm working on trying to develop, Azure as its own independent um classes so that it can kind of follow the same way that AWS does as far as the foundational practitioner, and then going into like more of the solutions architect and then to developer, and then putting that security piece there as well with networking security in the cloud, because they do, obviously on the cybersecurity side they do have classes as far as network security, but not cloud or
Okay.
cloud-based.
Sorry, I'm just taking some notes here because that's good information. So it aligns very similar to what we're doing, and that's what I'm trying to get more people as they share what they're doing in there and how we can move those in. So at 4 days, we were a big Cisco shop. I've been trying to steadily get them to get out of that because those days are numbered. Have been for years, but we're here. That's probably why I'm not going to be here, among many other reasons. But it's
Yeah, the
good to
Cisco
see.
is in part of the cyber, like the Cisco track is actually part of the cyber. So,
Okay.
I teach the students a way to get 2 degrees for the price of one by taking 3 extra classes, which is the full Cisco track, and also doing a SQL database, a foundational course in database, and then an operating systems course. And technically, they'll get 2 degrees, cybersecurity and network specialist.
Fantastic. Yeah, and that's really been the shift that we've even seen here on the cyber track. So, um, on the cyber track, it was essentially an extension of the networking, and then I had a layer of classes over the top. So they would still do their CCNA 1, 2 to get their fundamentals there. They would take their Linux and their Microsoft courses. So they had that foundation, and then I kind of came in at the SOC level or security operations side, where they would start understanding logs and actually putting all that information together in one spot. Um, and I see more and more schools mapping to that. And then, like you said, how do you add AI into there? And that really gets into like those log file analysis, which you were talking about up above here, to see how they could start analyzing that piece. But really, it's the configuration of those routers and switches, and being able to do that is infrastructure as a code. That's kind of what I've been pushing on the networking people for a while. Is while not everything goes cloud, it doesn't have to be cloud to still do your infrastructure as code. And that would allow you to get more version control, better understanding of what's out there, better reproducibility. And now that you have tools like AI to help with that, because if anybody's ever done infrastructure as a code, it's not easy. There's so many key terms and things that you have to memorize, and the templating structure is a nightmare. A good example of that is in the Docker side or VMs. I think most of you guys are VM based, right? You guys understand the concepts of VMs more than containers.
Yeah, both
Okay.
actually.
Both.
Learning more
Okay.
about containers.
So, and that's fine. I mean, that's where a vast majority of people were, especially with, VMware, where it used to be, and now it's kind of falling off, and everybody's much better on the Proxmox side, especially where you can do a good blend between containers and VMs with Proxmox, making it more easily available to students and instructors. The good thing is definitely getting virtualization in there. I think most schools are getting that now. They were behind a little bit in getting that, and I think now everybody's kind of caught up. At least a basic virtualization class where they understand the concepts of containers and VMs and the usefulness of those, when to apply which for which service. But that infrastructure as a code is huge now. So when I built this new company, obviously I didn't want to have to hire anybody to do the infrastructure, especially it felt guilty after having done that for 20 years. I should be doing that, but I shouldn't be spending my time doing that because it's not bringing money in the company necessarily. And so now it's all built out as code, and I can do that in a reproducible way where I can sit down, I link together physically the routers and the switches and the stuff I need there. In this case, last install was all a Ubiquiti setup. Well, you have to click and configure and do all that. It's not in the Cisco realm, but very popular in what's going through there. And then deploying the virtual machines and the services, including getting the servers themselves stood up. So if I'm using Proxmox or what else under the hood, getting those basic levels set up all the way through to the monitoring and how those systems are working. That seems to be the biggest push now, and I'm getting more people asking me that than even the software development side. So this is kind of an overview of doing that DevOps type thing, and I'm just going to lead into this before our next break. But the idea here is that AI runs that control plane for me now. So I interact with, in this case, it's Claude Code that's tied directly into my infrastructure. I also have it to where I have a custom chatbot that's trained just specifically in that realm, and that's done through system prompts and multiple MCP servers, which is the best way to do it, and training those as little bitty tools. So I'm not paying out the wazoo for the AI costs of things, but it works extremely well. So at the edge, I can have it tied in with Cloudflare. It can run my load balances, doing my DNS entries, all of that I no longer have to do by hand. I know what it is and where it's going, but I can trust that this will do it the way I tell it to set it up. And then on the compute side, I can hand it a blank server as long as I get the basics of Proxmox installed and hand it off. At that point, it will go ahead and configure it all consistently across all my different servers the way I want it. That way, when I'm doing updates or processing, I don't even have to do those. I have MCPs built out to interact with those systems, making sure you have things like Proxmox Backup Server, Docker Swarm, or all these different tools that are managing the entire infrastructure under the hood of that. And so this is really what I'm seeing more and more networking systems going to, especially as they get more into DevOps, because being a true networker anymore is kind of dropped off. You have to know more than just networking. Pure networking jobs are failing fast. A lot of employers are coming to me saying that we don't have pure networking jobs anymore. They need to know a little bit of full DevOps or even SysOps just to understand that those jobs are combining with each other. So this is kind of a generic way of looking at the operation and how they come in and how everything gets co-load between different locations, but everything's written out as infrastructure as a code. And that's kind of what we're pushing out to students more and more, is understanding these key terms, all these different technologies and how they exist together, both in the cybersecurity realm as well as the networking realm. So on the security side of things, we'll start using more. Waza is a great example of being able to get log management into one and doing tracking, whether you're pulling in third-party CVE lists and then being able to check your equipment against that to make sure you're not having issues. That's a lot of the software and the pieces that we push together, and quick front ends. A lot of these tools get real expensive real fast, and with the ability of some solid background knowledge and some Claude code, I can pretty much regenerate a lot of those programs from scratch, at least the pieces that we actually need for the business. And then at that point, you only have your AI cost on the overhead. I was curious how many other instructors are pushing down that realm at this point. So we're coming up on the 3 o'clock hour, which is where they wanted us to have another little half-hour break. Then we have about an hour and a half for the rest of the day. I anticipated more issues on the Docker side, and maybe not too many people were following along there, because I learned from last fall that getting Docker set up and some of these other pieces might take a little while. Is there anything else, you guys, for a foundational state that you would like to see more of in that last hour and a half? In other words, would more labs be better for use in the classroom? Is it a visualization thing? Or is everybody kind of up to speed on tokens and inference and how our context window all match together and understanding that full RAG pipeline? Yeah, no problem, Chris.
Everybody's probably in processing mode.
And I know that all too well in that group there, Terry.
No, this is fun. I got it all. I was trying to do it on both of them at the same time, and I was like, "What am I doing? I'm gonna fall way behind here." But
yeah, no, and my goal was to kind of walk through with those labs. So one, they were in the recording, but two, now kind of give you guys time, and I think that's what Daryl's telling me there is some free lab time so that you guys can kind of poke a little bit with that, and get some more hands-on what's going in there. So
yeah, as you know, I was thinking more experience with it because we were setting up the environment with like a virtualization servers and downloading some of those vulnerable VMs and doing kind of a hacking in that sense. But I'm trying to figure out how to use this instead to do stuff.
Yeah. And a lot of that was building from scratch. So like that CTF generation that we built out,
Cool.
Might actually bring that up. Do you even know what I called that? I've got too much stuff everywhere.
I got that somewhere because I used it a few times for some because I wanted them to do some incident response, like event viewer, and then what we did Wireshark stuff. We did some PCAPs,
Yeah.
especially since that's evolved in the cybersecurity competitions. That was helpful.
Good.
I at one point too that I forget what it was. Somebody would show me. I know we got we do security onion training now. We do what's the other thing? Show them how to see an attack that took place and investigate it and figure out what happened here. But one day I want to find out what you kind of do with how you use this in your classes.
Yeah. Well, that's like I said, this is kind of my last year in working with academia. I wanted to dump everything off to everybody I could because I don't hold on to anything. So
what is Juice Shop? So
yeah, OWSAP Juice Shop was basically there was a tool out there called Damn Vulnerable.
yeah, web.
It's same concept. They're all in the same realm.
Oh, got it. Like web. Okay, got it. Yeah.
Okay, Alonso, using that last hour and a half for lab time. Yeah, I think that's fine. Especially if you guys got questions or you start to get a chance to play with it. I think what I'll do over the next couple days is we'll still have some of the Docker stuff, but I'll probably backplay that a little bit to show more of a GUI side away because it sounds like that's more of what you guys might want in the classroom, which is fine. So I can change those over the night here, and we'll have that up and going. All right, so we'll hit that 3 o'clock just so I can make sure I honor their break times. We'll come back here about 3:30. Make sure I got that right. Yeah, 3:30. And technically that would give us 2 hours there after that. Like I said, this first day is a little tough because either people are going to get it right away or they're going to struggle in the lab side. So we'll use a good chunk of that remaining 2 hours to go over labs, and then anything else I want to kind of gather from you guys about what you want out of this week. We'll look at those topics, and that way I can make sure I make these workshop days worth your time. I know they're very long days, and I found that out with these workshops in NITC. They got to get you those contact hours, but I also don't want a bunch of dead time. I want you guys to get out of it what you can. So we'll see you back here at 3:30. No problem, Chris. Like I said, I built tons of time into the. All right, so coming back from the break here, looks like Terry had some questions on cybersecurity clubs and was looking for some feedback. So if anybody's doing competitions or like that with their students, by all means, reach out. Those are the kind of things that we like to build and see what we can do on that side too. So. As I'm looking here for the rest of the day, I think sounds like some people want to get caught up on. Good job there, Tara. I like it. Looks like people want to kind of go through some labs, so I think I'll give you guys about an hour just to play through some labs, and then the last hour of the day we'll kind of come back and make sure we're all happy with the direction and how we're heading with the rest of the week and some of those topics, and see if there's anything you guys want to expand. I took some good notes of what you guys had, so I really plan to show you guys how to use some of those tools that you guys mentioned to emphasize things like RAG and how that would look like, particularly from a networking and cybersecurity student, especially an entry level one, and how they could take advantage of little tools like anything LLM and those kind of things to RAG over logs, and we could do some analysis in that way. I think that's pretty common, pretty straightforward. Some of you did mention in your skills you'd like to see AI assisted pen testing, and there are some models out there to do that. They're a little interesting to go through. There's like Pentest GBT and Kali's GBT, and I've played with a bunch of those on the red team and the blue team side. We could spin up one of those if that's of interest in that side. But like I said, if there's anything else you guys are thinking of as you go through here, and want to expand on, by all means, let me know today and I can get it added in here for the rest of the week. If I am hearing everybody correctly, you're more looking to add things to your existing classes than you are to design a brand new class focused on AI. It's more how can we sprinkle the use of AI in with some of the classes we're already teaching. At least that's the impression I got. So if I'm wrong, definitely let me know and make sure I got the right direction. And I guess that does kind of lead into on the Sec AI Plus. Obviously, the concept of this course is for that certification. I still want to cover at least the concepts that are in that certification, but it does sound like you guys may potentially want to diverge in terms of actual content and things like that. It's obviously still going to fall under the Sec AI, but is there anybody that was specifically looking for, I need this certification, so I need a full 100% prep for it? Or are you guys more wanting to use the concepts out of Sec AI to bring into your classroom? Which angle is most people leaning towards?
More the latter for me. I'm looking at sorry, the former. I don't have a specific date for the cert yet, but at least partial coverage of all the domains would be very helpful.
Okay. And I think that's kind of where we're at is, I think I covered in my original plan, I was covering anywhere from 80 to 90% of everything that would be on the cert. And then I think now what you guys are looking for is just how those are applicable in the classroom as well. So. Okay, great. We got a good balance of both. Like I said, there's definitely not going to be a shortage of covering the concepts and the topics out of that certification. They do weigh it fairly heavy. The exam at the end of the week here is kind of I don't want to call it a prep exam. It's about 30, 40 questions from actual question banks from the cert exam. So I want to make sure we at least cover those topics as we go through there. Big chunk of it is all in the securing the AI system. So making sure we understand how we can rate limit those systems and do that kind of thing, which frankly is the reason most of this is set up in Docker. So because you can't really demo that type of thing in LM Studio because you're not dealing with the model at that level. So we'll still have some of those labs, but also what you can utilize in the classroom to teach some of the concepts. So I don't want to get too far off track from the Sec AI thing. All right. Like I said, I'll give you guys about an hour to get caught up in labs, kind of poke around a little more with those other tools. And then we'll spend the last hour kind of recapping and making sure we're staying focused on what we got here. All right. So hopefully that gave some time for you guys to catch up on labs. Obviously, you got plenty of time to do that. And those first three there, we're just trying to get you introduced to that Docker setup. I am planning on shifting a little bit more towards anything LLM or LM Studio just to give a little more visual representation and then some other ideas in there too. But we'll definitely have a good start here for tomorrow and get set up. Tomorrow is really going to be focused on the threat model. And so this is kind of the big chunk, about 40% of what that certification exam is all about, is being able to protect an AI infrastructure. So you guys will set up this AI infrastructure here tomorrow and be able to protect that a little more from prompt injection or indirect injection, how to exfiltrate data off of that. So we're going to make some weak LLMs. You guys will attack those, and then clearly how we're going to go through and protect some of that. So most of this information I'll get pushed out here tomorrow morning. I'm going to have some additional labs. It says 4, that there's going to be more than that now. And get tomorrow to be more of a hands-on day. There'll be still some labs and some lecture there, but I'm more, like I said, of a hands-on guy. I'd rather live demo it and then let you guys walk through it as well. That way, if you have questions. Another little shift that I'm going to have here for tomorrow is not only will it have the labs that are focused specifically on the SEC AI, but it's also going to have some labs that will be more focused on red team, blue team. So you'll have one of each, so that they're applicable within the classroom as well. So same concept, like here we're protecting the LLM, but also how you would go about using that LLM for log analysis and a bunch of those other things you guys listed. So looks like we should be able to get that incorporated here this evening. Anything else anybody can think of that they wanted to see this week or they had in their mind that that's why they signed up for this event? Okay, great. It sounds good, Andrews. Like I said, I really do like changing these in the evening to kind of match what everybody wants. So if it sounds like it's a lot of work, that's what I do at these events. We'll definitely cover a lot more content here in the next 2 to 3 days. Definitely take the time to take a look at those end of day quizzes. That's kind of what I'll leave you with here for the last hours to finish up any labs that you want and kind of do those end of day quizzes. Those will help prepare you for that exam that's on the final day there on Friday. Like I said, in order to get the Credly badge that they want everybody to have, there are a bunch of questions from the SEC AI cert, and on Friday, I believe it's a 30 or 40 multiple question kind of scenario style questions, maps very closely to the cert. And you guys will be able to take a retake on it too if you want that kind of thing. No, I won't have any voucher, Mohammed, for that side of it. All these training materials are essentially I don't want to call it unauthorized, but unofficial content that would prepare you for that particular cert. It's not a genuine cert track, as that would have cost everybody money in order to do that. So, okay, great. Like I said, I mapped real close to this cert. I myself was going to take it, and then I got swamped in the new company there, and I didn't get a chance to do that here before the workshop. But I'm positive that a vast majority of this content would hit about 80 to 90% of what's on that cert. All right. So, like I said, I'll probably end the recording and in terms of that for the rest of the day. The remaining just shy of an hour that we have here will be available for you guys to take a look at that. All the materials and everything on this website at the end, I'll actually have a zip file that you can download the entire website with all the materials and everything included. That way you can launch it as a simple Docker container on your machine and it comes up like a website or kind of a standalone event. So that's pretty easy to do. I'll also leave it on this URL here for several weeks past the exam, usually because I forget about it. But it will definitely be up for quite a while. And that way, if you want any of those materials for the classroom, you can do that. If there's any other resources or stuff along the way, let me know. I did throw a bunch here in this resources tab, and I'll keep growing this every day with different tools that I talk about or different software packages that you could use to kind of help you get to set up in the classroom. And then that last day, I have a showcase in here. This is really, I like on that last day to kind of go beyond what the workshop was intended, meaning that a lot of you are wanting to try to get this in the classroom. So if there's something last minute you want to set up, how to get these different environments set up so that you can help students, we can certainly do that. We've done anything from build AI tutor bots for your students for your different classes that you could integrate into your classes, whether you use Blackboard or that kind of stuff. You could kind of find ways to integrate that. Being able to understand MCP servers, that way if you guys are trying to build stuff on your own, what's the best way to build those out? So we'll definitely cover that. All right. I'm going to be, like I said, hanging out here. I wanted to give this time for people to catch up. I know it seemed a little slow today, but that's mostly because I built in lots of time for getting people's environments stood up because we're going to go pretty hard on the lab environment here for the rest of the week. Anybody else has any feedback, you can certainly email me. I think all that's listed there. And or if you're going to be out this week or something comes up that you know that you found out, email me. That way I can at least get it notated on the attendance sheet, and that way you can qualify for your Credly badge at the end.
Thanks, Jason.